Not quite.
What's that?
Sorry, it was getting started.
Okay,
We are
still
now
going?
getting started. Sorry, the stream was getting started. Hello, everybody, and welcome to today's event. Today's event is being recorded on behalf of the Microsoft Corporation. If you do not consent to be a part of a recorded session, please disconnect your line at this time. The recording will be available at the same location you joined today's event. To learn more about the ways you can participate in today's event, please click on that messages button in the lower left-hand corner of your screen. We encourage you to interact by using the messages panel at any time to ask questions regarding content or to request support. If you experience any technical difficulties, please refresh your browser or press the Refresh Now button on the information panel. If this does not resolve the issue, please send in a message and we will be happy to assist. There is also an online test page if you wish to self-support. Simply click on the Help button in the Information tab. And now I'll pass it over to your presenter, Dwayne Natwick, Cloud Training Architect Lead.
Thank you very much, and welcome everybody to this Azure Fundamentals Exam Cram. I am Dwayne Natwick. I am a Cloud Training Architect Lead for Opsagility, a learning partner for Microsoft. I am also a Microsoft Certified Trainer and a Regional Lead for that program, as well as a Microsoft MVP in Azure. I hold multiple certifications within the Azure role-based environment, as well as which includes the Azure Fundamentals, as well as some of the associate and expert certifications that go along that are kind of the add-ons and additionals after you have gone through your journey of Azure Fundamentals. And I am active on social media, and feel free to contact me, connect with me on any of the links here, during or after the presentation, or even reach out to me at my Opsagility email. So, I probably have some people that were in the initial 8-hour session a few weeks ago, or have viewed or listened to the on-demand content on that. This is a scaled down version of the content that is within Azure Fundamentals that's really geared towards preparing you for the exam. So just to kind of give you an idea and understanding about the exam, that the exam, Azure Fundamentals, is a foundational level concept, and where it goes over cloud concepts, the core Azure services, security, privacy, and compliance, as well as pricing and support within Microsoft and Azure. It's really for those that are beginning to learn about cloud computing, or even if you've learned about cloud computing, you're just getting into the Microsoft Azure space. This really meets your needs there. This being a fundamentals course, there's no prerequisites for this course or for this exam. And this exam really isn't a prerequisite to any of the associate or expert exams. However, I always recommend that if you're new to the Microsoft Cloud environment and have never taken a Microsoft exam before, that taking a fundamentals course and exam gets you really in the area of understanding what to expect in terms of an exam, what to expect in terms of the content and how it's presented to you, and it gives you a good, strong overall foundation on everything Azure before you really start to specialize on certain areas, whether it's to become an architect, a developer, an administrator. It takes you down that path. And once you do take and pass the AZ 900 exam for Azure Fundamentals, you are considered certified. You get a fundamentals badge. One of the nice things about the fundamentals exams is there is no expiration date to them at this time. So they continue to be applicable going forward. They do update them regularly, and I'm not saying that they're never going to be need to be renewed. But one of the nice things Microsoft has done is actually renewing exams like the associate and the expert exams right now. They've done that in terms of an annual assessment exam, rather than having to retake the exam as with a lot of the exams previously. So to understand the exam, it's important to understand the objectives. And the objectives of the exam, there are 6 objectives to Azure Fundamentals, and we'll go through each of those objectives Again, if you've gone through the full 8-hour, we covered these in great detail as part of the full course. We're going to cover them at a much of higher level of here's some things that you should really focus on and really need to know around each of these. And we have our core cloud concepts, our core Azure services, core solutions, then network security and general security, identity governance, privacy and compliance, and then cost management and service level agreements. And to give everybody an idea how this is going to go here in the next 4 hours is we'll go through these first 3 modules in the first group, and then we'll take a 10-minute break and then hit the next 3 to finish up. So that's how we're going to kind of break it up 50-50. And as you can see, based on the weighted portion of the exam, that's pretty much how it weights as well. Pretty much every area is fairly weighted equally, with really cloud concepts being a little bit higher weighted than as well as identity governance and privacy. It's just really because of the content and the level of understanding that's needed for those, and where they kind of create that foundational approach to everything is why. But really, for the most part, you can expect kind of an evenly spread exam based on all of these courses. And then if you want to know more about all of the concepts and everything, there's a link on this slide. The slide deck will be provided to you after we finish at the end of the course, or at the end of the session here today. And the links provided on the slide, so you can very easily get to the Microsoft Learn content and the exam page to understand a little bit more about how these are broken up and what those core areas are. And Microsoft Learn is a great place for free content, free information, free documentation, and everything that you need for gathering, for learning and continuing your path to learning and reinforcing what I've talked about today, what the 8-hour course has gone through. It's a good reinforcement tool, and again, a free tool for learning within Microsoft. So let's jump right into Objective 1, Cloud Concepts. And like I said, this is, there's a group of concepts within. We're going to cover kind of your basic concepts around what is cloud, and then what the basic service models are, types of cloud delivery models, and what does it mean to be in the cloud in terms of what is your responsibility, what's Microsoft's responsibility, and those all go within here, and that's really what we're going to cover. And these are the key pieces that you really need to know to before you take the exam. And first and foremost is the cloud models. And what is cloud computing? Understanding public, private, and hybrid, and how they differ. And we'll go through that here real quick. So, cloud computing, and one of the things that I go through when I do the full 8-hour class is kind of the evolution of cloud. But really, in a nutshell, what cloud services are and what cloud computing services are is you no longer are making capital investment to a data center building, the hardware and the networking and the storage that all goes in there. Cloud, Microsoft is now renting those services to you in really a subscription service. So the core components of cloud computing are that building, and then you aren't really renting the building. Microsoft's providing that building, and the building to you where everything is, but they're providing you with that compute, that networking, that storage, and then really the analytics that go all along with that as well. All of the monitoring and all of those capabilities to manage it is all part of the platform of cloud computing. Your key components of cost as well, when we talk about cost later on in the session, compute, networking, storage are those key pieces and areas of cost as well, of what you're going to be consuming, what you're going to be utilizing within the cloud. And the benefits of the cloud are that you have now Microsoft with all of this compute power, all this networking power, all of this storage capability, giving you a level of economies of scale, because they have thousands and thousands of customers that are now utilizing this hardware in one way or another, and it's being parsed based on customer. So you pay for what you use, and you're gaining a level of economies of scale because you are saving money because you're not the one investing in it for your company alone, and you have the ability then also to very quickly and easily stand up and create new resources within your environment. And when we're talking about Microsoft Azure, what we're talking about is public cloud. And here the key pieces to understand around public cloud is it's owned by someone else. You generally Azure for Microsoft, or if you're familiar with other cloud providers like AWS or Google, we have or another hosting provider. Maybe it's a private company that hosts services. Then it's owned by them. It's a public cloud. They're generally providing resources to multiple organizations and users, and you're accessing that through the internet, or maybe a secure connection, some sort of dedicated connection, such as an express route with Microsoft or direct connect with AWS, or some level of direct connection. But you're ultimately connecting it through a network, tied into your network. And it might be privately through the publicly through the internet, or privately through the internet, but you're still connecting somebody else's resources. And that's the key thing around what public cloud is. And to understand public cloud is understand it's hardware owned by others. Private cloud is hardware owned by you, the organization, or the customer. You build your own data center. You're responsible for the operating of all of that, and you do not provide access to any other outside organizations. That is a private cloud. It's in your building. It's all of your networking and your hardware. Those are the key. That's the key differentiator between public and private. Hybrid's just a combination of both. The easiest way to remember that is it's just, you have an application running in your own data center and you're utilizing Microsoft 365, or you're running a web app on Azure. You are now running a hybrid cloud environment rather than a private cloud anymore. So that's really where it comes down to, is you're utilizing both of those components for certain applications within your organization. You are now consuming hybrid cloud services. And the key things to understand and key points to understand is, with public cloud, to scale up and scale out your resources, there is no capital expenditure. It's very easy to just create a virtual machine or create an app service and move on. They very quickly and easily as well, and you only pay for what you use. So generally, you're now moving from a capital expense to an operating expense, and that's kind of the key thing to understand there around public cloud. When handling a private cloud, you have to purchase all of your hardware, understand what your maximum capacity needed might be, and you have complete control over it, complete responsibility for all maintenance and updates. The issue here is, and what I always use in terms of a private cloud versus public cloud, is a website. If you think about your website and hosting your website on a private cloud, you need to determine that, and your website has e-commerce capabilities. You have to buy hardware that is going to support the Christmas season. You're going to have to support November through January, where your website is going to have a lot more traffic than it's going to have February through October. You might be running only 25% of capacity of that hardware those other 9 months, or in my example, other 9 months from February to October, just to be able to have enough capacity for November, December, and January. That is not the best use of capital money, because obviously you're not running at capacity. You're depreciating that hardware month over month for only being, and it's only being 75% of it is being underutilized for that amount of time. What you can do with public cloud is you you deploy that website in Azure. You only deploy it for the processing power that you need for February through October. And then when becomes late October and you're getting close to Christmas season and your Christmas specials going out through marketing, you increase that service plan for the next 3 months. So you're only paying for what you use. You're only paying for the compute resources and the amount that website's being hit during that time period. So it's very helpful there from that standpoint. Hybrid cloud provides the greatest level of flexibility here because in a situation where there might be applications that can't run in Azure, or they can't run within within a cloud environment, or need higher level of security, then they do not, they can't go to Azure. So you need to keep that in a private cloud. So you run that in a public cloud. So just want to pause for a second. There's actually a good question that came through the messages. Is it possible to have owned hardware on Azure like private cloud on premises? There is certain situations. There is nowhere where you have owned hardware on Azure. Microsoft does not co-locate your own hardware where you own it. There is isolated instances that you can create that you have dedicated processing power that no other Azure customer has access to that compute power, or reserved instances where you're saying you're going to use this amount, but you still do not own that hardware. Microsoft does own all hardware. They don't co-locate like an Equinix or a Rackspace would, where you can actually put hardware within their data center. But really good question there to for a level of understanding. Azure is a full public cloud. There are some hosting providers out there that do both, where they will actually provide you with multi-tenant type services, but also you could bring your own hardware and just buy rack space in there. Azure does not work that way. But really good question there. Hopefully that helped to clarify that public, private, and hybrid. When we're talking public cloud, we are very strictly, and talking about Azure, that is a public cloud. There is no public cloud capability. Anything within Azure would be considered public cloud. So somebody asked, again, follow-up question, dedicated hardware on Azure would it be considered public cloud or private? Everything on Azure is public cloud. Like I said, you don't own, if you go back and think of the definition of private cloud, the organization owns that hardware. They own it. They are responsible for the hardware maintenance and updates. Even in a isolated hardware instance within Azure, Microsoft still owns that physical hardware and is responsible for the maintenance of it. So it's still a public cloud. Thank you for that clarification. Let's go through a couple quick knowledge checks. Just this is in a bad space. Hold on one second. I gotta move this. Just a second. Have this in a wrong area here. Do not want to get to that. Just one moment here. Sorry about that. Got my slides out of sorts there. There we go. All right. So let's talk about a little bit more around the benefits of the cloud before we get to a knowledge check. My apologies there for having that out of place there. When we're talking about the benefits of the cloud, and I've hit on a couple of these already, we talk about generally a group of these 10 areas here are really the key benefits of the cloud. We have high availability, fault tolerance. Microsoft's providing all of those capabilities within their infrastructure. They have data centers all over the world. So you have the ability to very easily scale into other markets as an organization. So you have scalability, the elasticity, which we hit on in terms of the one of the benefits of public cloud is being able to create resources very rapidly and decrease resources very rapidly. Again, the global reach goes along with that whole high availability and even fault tolerance within within the infrastructure. When we're talking about fault tolerance, we're talking about the Microsoft has generally at each data center data center region, they have multiple data centers that are also on that campus, as well as then the global reach. Customer latency capabilities. You can build in capabilities to decrease that latency to bring if you, rather than having your own data center that might be somewhere in the United States and somebody in Europe needs to connect to that, there might be some latency. If we need to, we can use that global reach. We can duplicate those resources closer to that customer or use some sort of content delivery network to deliver that information with decreased latency. Agility goes hand in hand a lot with elasticity, being able to be very agile to what's needed. The ability to predict cost. There is Azure Advisor that provides some predictive cost capabilities to be able to continue to understand what your spend is. And then disaster recovery again, goes hand in hand with high availability and fault tolerance. If you need to have disaster recovery capabilities and have, say, a warm site for your data center, you don't need to buy a new data center. You can very easily stand that up and utilize Azure as a disaster recovery site for your resources. So you don't need to necessarily go through the process of capital expense to rent a new facility, build up all the networking and everything for disaster recovery. You could do that very easily in a public cloud environment. Some security capabilities, and we'll talk more about this as we go through security and go through compliance and everything like that. Microsoft being the company that they are, and the international organization that they are, handling companies from around the world, they have very strong security baselines that they adhere to protect governments and countries within their environment. So at a baseline, they're probably in a way more secure than you are within your own organization, depending on how serious your organization takes security. Everybody takes security pretty seriously, but Microsoft obviously has a lot of customers that might have stronger security considerations than your organization might have, and then you can take advantage of those best practices that Microsoft's put in place. And I've hit on this when we're talking about the difference between public and private cloud is the shift. When we are running a private cloud, we are doing a level of upfront spending of our money to buy the infrastructure, and we have to go to executives and management and request that money. I need $200,000 to build out this data center. And they're like, they don't want to do that, right? They don't have the money. You might be a nonprofit organization and don't have the capital ready for that type of investment. The public cloud allows you to pay for what you need and turns it into an operating expense, just like your internet service, your television service, your utility, all of your utilities. It makes your cloud, your data infrastructure, your network infrastructure, your server infrastructure become more of a operational expense or a utility that you only pay for what you need and pay for what you consume. It's much easier on the books, much easier to justify in that regard. And that's really, cloud service provider, it's based on consumption. You pay for what you use. It helps you in predicting your costs because you can get an idea, after you're on the cloud for a few months, understand what that cost is and how that's going to affect your operational bottom line, and you're billed only on that actual usage. And then when we talk about the different services, let's talk about the different types of services now we're talking. And again, these are public cloud-based services. There are three that we talk about. It's infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service is really your first, really generally how everybody makes their first move into the Azure environment. You rent those servers, the virtual machines, the storage, the network, but you still manage the operating system. You manage, the application. It looks very similar to what you're running in your own data center in a VMware type environment or OpenStack type environment, but where you have your virtual machines, but you aren't investing in that hardware and that management plane anymore. Microsoft's providing all of that to you. Generally, what you see here is the use of this is you're taking an application that's running on a virtual machine in your data center, and you're moving it directly, you're migrating it directly into a virtual machine in Azure, and that's generally called a lift and shift type migration. Platform as a service is where we start taking advantage of what Microsoft has within Azure for providing services, providing the benefits of operating system management and patching and tools that they have within the Azure environment that you don't necessarily have at your disposal in your own data center or in an IaaS type environment. And it's really now focuses on the development of applications and focusing your organizational time and your organizational overhead on creating strong applications for your users and for your customers, rather than maintaining and managing operating systems and hardware and all of that. So platform as a service is really where we're going to really start taking advantage of the cloud, of the public cloud benefits is with platform as a service. Software as a service is where now you're just really, as a user, connecting to applications, and this is such as Office 365, Microsoft 365, Facebook, Salesforce.com, Dynamics 365, all of those purchase by user type applications are software as a service. You don't have any hardware. All you're managing is the users that are on there and how you're protecting your data. Couple questions that have come through here that I wanted to cover real quick before we go any further. I will talk. So one of those questions is, how do you gauge security level for education purposes? I'll talk about that for when we get into like compliance and standards here in, I think, module 4 or 5. So we'll hold that question for right now. Another good question around the difference between infrastructure as a service and platform as a service. Yes, when you are in infrastructure as a service, you do get the operating system. The difference between infrastructure as a service and platform as a service, though, is in infrastructure as a service, when you create a virtual machine with a Windows or Linux operating system, it's your requirement, and we'll actually go to this in the next couple slides and talk a little bit more through it, but you are still responsible for managing that operating system, for patching that operating system. Platform as a service, you get the operating system, and Microsoft will make sure that it's the most up-to-date and latest stable version of that operating system at all times, so it takes that overhead off of you. But really good question there. It's kind of, understand that in infrastructure as a service, and one of the things with infrastructure as a service is you do have the option to bring your own license within Azure. But they also provide you with that. You essentially purchase that software when you purchase a virtual machine with, say, a Windows operating system on it. Microsoft's really just selling you that license, but you have to manage that operating system. Platform as a service, you no longer manage that operating system and don't really have access to that operating system anymore to do that management. Well, really good question there. And just here's again some key things to remember around infrastructure, platform, and software as a service. We have, infrastructure as a service provides the most flexibility based on what you have from today. What you might have in your own private data center. It provides the most infrastructure flexibility. You configure and manage the hardware for your application. The operating system for that. The operating system. You get to pick the compute capacity, the RAM, and all of that. So it's the most similar to you purchasing your own server or creating your own virtual machine in, say, a VMware environment. From a platform as a service, again, focus on application development. The cloud provider provides all of that management from the operating system, antivirus, anti-malware on down. And then your software as a service is that pay as you go. I need to have my email and productivity services. I'm going to buy Microsoft 365 based on how many users I need. I set up the users and they have access to those applications. You don't have to build any applications. Those applications are all set and ready to go. And this kind of outlines it a little bit more in terms of, especially with that operating system question, to understand how the responsibility works now. And when it's important to understand our shared responsibility and what we're responsible for within cloud, the different cloud services and the different infrastructure models. When we have our on-premises environment, obviously in our private cloud, we're responsible for everything, all the way down to the physical infrastructure, physical building, and everything like that. Within infrastructure as a service, Microsoft's providing you with the physical compute, networking, and storage. You then are responsible for managing the sizing of that virtual machine, which operating system it's running, and patching and providing the runtime and middleware type aspects of it for anti-malware and all of that. You need to put those extensions all on those virtual machines so that they are protected properly. And then you have to then install the applications, and you're responsible for how users access and how data is protected on there. Platform as a service, really your only responsibility. All of those other things that have to do with that platform is Microsoft takes on the responsibility for. And then you have your applications that run on it and your access to users and data. So software as a service, then again, you just are putting users on there. You're determining, how data is shared, and that's about it. So if you think about Microsoft 365 and, sharing files or folders on OneDrive and how you're allowed to do that and what you have access to when you log in to Microsoft 365, whether you have admin access or anything like that, those are key things there. And I'd like to kind of provide kind of that a level set of shared responsibility by utilizing Pizza as a service, which is a very helpful tool. I saw this years ago when first learning about the cloud, and just kind of bring it about when I'm always talking about these these fundamentals courses and talking about shared responsibility, because it really gives you a level of understanding of what we're talking about here, where we have in our private cloud, we have our traditional on-premises pizza here, where we make the dough, put all the ingredients on the pizza, we cook it, and then we serve it. Infrastructure as a service, think of this as like you go pick up a DiGiorno or a Red Baron pizza at the grocery store, and then you can then you take that home, throw it in the oven, but you're providing that oven, you're providing the fire, you're providing all the utilities as part of that. and that's really where that and the table and everything. The delivered pizza falls into that platform as a service because you're no longer you're getting it hot. It's ready to go. We just need to now cut it, serve it, and provide the beverages, which ultimately fall into that kind of application piece. To enjoy it, we can add probably plates and knives and forks as part of that whole application area as we serve it. And then finally, going to a restaurant, going to a Pizza Hut or Italian restaurant and ordering a pizza. That's really where software as a service comes in. You're not providing anything except for you showing up. So those are that kind of brings that together for you, hopefully. Another piece that kind of has kind of come into play as part of another one of those as a service type models is serverless computing, and we've seen some models that adds functions as a service in there as well. Similar to like a software as a service, we're no longer dealing with compute, but it kind of falls in between that platform as a service and software as a service type realm within the Azure environment with these two types of services, Azure Functions and Azure Logic Apps, and they're considered that serverless computing where you're really just running code and doing some level of a workflow generally is what an Azure Function and Azure Logic App does for you. But really, and we'll talk more about them when we get into solutions as well. Mention Azure Functions and Azure Logic Apps again. The difference between the two is they both run some kind of workflow or some sort of trigger event that does some action. Azure Functions does it more as a code. Azure Logic Apps is more of a graphical type process. It's very similar to like if you've ever worked on if this then that in a on your smartphone and use the if this then that app. Azure Logic Apps works very similar to that. So now let's go into a quick knowledge check that I'm just going to run through here for everybody. Which cloud service type requires the customer to manage the underlying hypervisor platform? When we talk about the hypervisor platform, we're talking about that management plane of things within the environment. We're talking about the hypervisor, and this is actually none of the above. The hypervisor is actually part of the host system. If it said the virtual machine platform or operating system, we would be talking about infrastructure as a service. When if you see something like this, when we're talking about hypervisor, we're talking about the actual host. So keep that in mind. That's why that's none of the above. Here, which cloud service type would best match here? Several web applications have been developed internally in your organization. The web application allows users to enter details in a form, and those details are then emailed to a shared mailbox. The form is accessible from the internet and can be accessed anonymously. This actually becomes platform as a service. So this is where we're doing some application development. So we're doing a level of application development, and we can develop that website and those forms within the web app, and we'll talk about websites and web apps later on. Emails obviously could be sent using SaaS solutions as well, so keep that. But when we're talking about like web applications and creating web applications, best way to do that is platform as a service. Which cloud deployment model would be best in this following scenario? A server is needed to process data for a short-term project. The organization does not have the hardware to meet that. The project starts in a few days. So this is really where our elasticity and our ability to provision equipment very quickly in a public cloud type environment really comes into play. We don't need to purchase a server, have a server shipped in, and go from there. Another example here, we could also utilize the platform database if we need a database as part of this project. Next one, the capability of a system to be enlarged to accommodate a growing amount of work is best described by what term? And this one is scalability. Here, scalability is the ability to increase capacity very rapidly. We want to be able to do that. So that's what we're talking about there. Next one, in general terms, I'll slow down on the knowledge check a little bit. I think I'm going a little bit faster than the refresh rate of the presentation, so I'll slow down on this a little bit. In general, and everybody will get a copy of this slide deck, so don't worry so much about, I'm not asking you specifically to answer these questions right now. You'll get the slide deck that'll have this knowledge check. There's also a form link that's in there that I'm not actually going to go through in this 4-hour session, but feel free to use it. Use that for practice. It's publicly available. It's publicly accessible even after today. Feel free to do some practice questions and get yourself used to these questions. So, in general terms, when an organization moves to the cloud, will it see a reduction in capital expense, operational expense, or both? And this is, kind of a loaded question a little bit, but ultimately you might see both be a decrease. And it's, like I said, it's a loaded question because, most likely you'll see a initial reduction in capital expense, or even, if you don't use any capital expenses, and utilize, CapEx at all, it gives you an ability to move into operational expense. But you can start to migrate those depreciated components from your data center into the next realm of public cloud, rather than having to make another capital expenditure. In terms of operating expense, you could reduce that spend over time by taking advantage of some of those services, by moving some of those infrastructure services to platform services or to SaaS-based services. Over time, you could take advantage of some of those cloud benefits that we talked about here in the previous slides. So that's ultimately gets us through really module 1, or objective number 1, understanding those cloud computing concepts. So important to understand, and if you're preparing for the exam, understand those benefits that and really what public cloud provides for you in an organization. Key thing, and I'll guarantee you will get some questions on the exam to differentiate between private, public, and hybrid cloud, as well as IaaS, PaaS, and SaaS. So make sure you understand those to a certain degree, and understand the shared responsibility model and how that plays with infrastructure, platform, and software as a service as well. Those are kind of the key things there to remember as you go through. And like I said, we're not going to go through these knowledge checks here today in the short term, but like I said, those links are good, and good public links for you to practice as you go through this exam, as you go through this slide deck and prepare for the exam. Feel free to do that. So let's go into objective 2 now, which is our core Azure services. So we're going to jump through and talk about what the Azure regions are and their availability zones, subscriptions and resource groups, core Azure resources such as Azure virtual machines, the networking components, the storage storage accounts, and the different types of databases that are available within the Azure environment. So key thing to understand here in this quick section, we're going to talk about some of the core architectural components. So when we're talking about our architectural components, we're talking about things like regions and geography, the availability zones, availability resources, all of those areas all fall into there. And first and foremost, to understand is what a region is. And key thing to understand around a region for understanding in just terms, in cloud terms, a region is not generally a country. There are multiple regions within a specific country. When we're talking country, we're talking geographic areas. So as you can see in the map, which depending on the size of your monitor that you're looking at, could be quite the eye chart for you. But you can see, you could hopefully make out on the slide the continents, right? And we have our United States and North American regions. We have South America, we have Africa, we have our Europe and UK, our Middle East, our Asia Pacific, our Australia, all of those geographies there that really make up the regions of where Microsoft has their data centers. And so understand that these regions are generally within with separated for proper disaster recovery capabilities. They are built for specific governmental sovereignty requirements. For example, like we'll talk later on today, later on in the session about China. Germany and Russia have specific requirements around their data centers and how their data is handled. So those regions are handled a little bit differently than some of the other regions. Each of these regions generally has one or more data center within the area, and we'll cover that here in a moment. And you can see based on where we have the little white diamond, those are availability zones, and those are generally, we have 3 data centers within that region to provide a level of regional redundancy as well as utilizing geographic redundancy. And each of these regions create a level of region pairing that's utilized for our potential disaster recovery capabilities, resilient infrastructure capabilities are all within and understanding who these region pairs are. It's not a huge requirement from a test standpoint, but understanding when you're standing up resources, where these region pairs lie, because you're going to have capabilities and resources for that are going to match up between these paired regions. So if you have a new service that comes about in East US, you'll know that it's going to come online probably West US at the same time because they're paired up. And there's also high speed backbones between them for better for less latency, less network latency as well. And then, as I stated, the next piece of that pie is the geographies, and the geographies take place, are really those countries, those compliance boundaries that we talk about, and really, and I can pointed them out a little bit. We have the Americas, Europe, Asia Pacific, Middle East, and Africa. Australia falls in that Asia Pacific category of geography. We have Americas, which is our Canada, United States, and South America, Central and South America. Europe is all of the the UK and the European area. Obviously, the Middle East is the Middle East, and Africa is Africa, the continent of Africa. So these are based on those sovereign requirements and what they need to do in terms of compliance, boundaries, and resiliency, and all that within those regions. And there's multiple regions again within each of these geographies. Why is it important to understand availability zones, regions, paired regions, geographies? All of those is to understand when we're talking about high availability, resiliency, and building and architecting our environment. We need to think about the different availability options within our organization, and based on our requirements, and based on what level of availability and uptime we want to require as an organization. And you can see here, within an infrastructure as a service type environment, if we have a single virtual machine, it's 99.9% available. So, which means it could be down. I think that's about an hour a month. If we put more than one, put two or more in a availability set, we go up to 99.99, which drops that down to I think it's about a half an hour a month. So it drops it down quite considerably. And I think don't quote me on the percentages. I always get a little confused on monthly versus yearly and all of that. 5 nines is really like 5 minutes a year or something like that. So, but it does give you that additional level of availability there of additional decimal place down to 100th of a percent rather than the tenth of a percent. And as we continue to build up, we have these availability zones that we showed when we were looking at regions, where there are 3 data centers. They have different utilities, different electrical, internet, and everything coming in, so that if one data center goes down, you don't lose all of your applications because it stays up. So you have multiple virtual machines in one data center, you have multiple in others, and then you have a level of resiliency built in and high availability just built into that region. If we want to think more from a disaster recovery standpoint, now we look at our region pairs, and we can actually build a high availability environment with even more resiliency than we have in just being in our particular region. We can do that based on where we need our services. We're using, if we go back, if we think West US was, I think, paired with Central US, or West US 2 was paired with Central US. Those are a little weird. I'll use East US and West US because those are easy. East US and West US are paired together. So West US, obviously, from a natural potential issue, you have possibility of earthquakes or what's been happening, what happened this past summer in the western region with wildfires. In the East US, you have the potential for hurricanes and snowstorms and things like that. So, the possible dual natural disasters taking place in both of those regions simultaneously is slim. So you put resources in both of those regions, and then that if there's a power failure for one reason or another in one region, you're still up and running in the other. And this next slide shows a little bit more around availability zones and what they look like, where we have our availability zones provide that protection of downtime due to a potential single data center failure. And this is what I was saying. We don't need to understand this largely for this particular test, but understand what an availability zone is within a region. You have 3 different data centers, and you can have your virtual machines replicated and duplicated in those data centers. In addition, there are fault domains and update domains that go within the rack space within that data center, and those our default domains is spreading those virtual machines across different racks within the particular building, and the update domains spread across different hosts. So if there's a host update, we don't take all of our servers down at that time. And now we're going to get into the actual Azure resources and think about what we're really purchasing when we go into our Azure environment. What are we renting? And as I said before, with cloud computing, it generally means compute, storage, and networking, and then we have the monitoring and analytics of that. So, and these are all showing different when we think about like virtual compute type services, we've got virtual machines and app services. Functions fall into kind of that serverless computing service. Storage, that's really our storage accounts and our databases, and then our networking, obviously our virtual networking. And we'll talk more about the components that make up each of these here in the subsequent slides. And the building block of everything that you create within Azure is a resource group. And what a resource group is exactly that. The really easy thing to understand within the Azure environment is they keep things pretty simple and pretty standard, where a resource group is that it's a group of resources. It's really creates that containerization of your resources and what you have within there. And you can do that multiple ways. You can look at it in terms of separating by different regions. So if you want to make sure that there's a level of governance of my resources that are in Europe versus my resources in the United States, create a resource group in the United States, create one in Europe, and everything that pertains to either of those regions and geographies go into that resource group. You can also separate it by specific applications, by specific use, departments. There's a lot of different ways that you can handle those resource groups. And and it doesn't mean that just because you put resources in a particular resource group that they can't communicate with resources in another resource group. If they're in the same tenant, they can definitely utilize resources within there. And this diagram kind of gives you a little bit of that. This is showing, first example, we have a web app and a virtual machine and a storage account all within the same resource group doing the same thing. But we could put all of our web and databases in one resource group, our virtual machines in another resource group, and a storage account in another resource group, and still link those accounts and still link those services together. So it doesn't block us from being able to do that or create an issue. It's just really how you want to do it and what best way from your organizational standpoint is it to containerize your resources. Azure Resource Manager is the way that we manage and we support all of our resources. It is our management plane across how we view and create resources, how we understand what resources we have, how we find out cost and remove and update all of our resources is within Azure Resource Manager. And there's multiple ways to access Azure Resource Manager, and we'll talk about a few of those tools at a high level. But we have the Azure portal, which is the web interface. We have PowerShell. We have Azure, the command line interface. And then we have also REST API clients that we can utilize for Resource Manager. And if I was to go into and show you here, we're within my Azure environment. I'm within a resource group within my environment, and this is within Azure Resource Manager, or I'm within the portal. All of this is really my management plane of Resource Manager is all built into the Azure portal. So you can see all my resources here. I have a virtual machine. I have a network security group, which we'll talk in a little bit. We've talked about Azure App Services. We've talked about storage accounts. I have all of that within my environment. And if I go back home and I view my resource groups, you can see I actually have a few different resource groups. I have this resource group here that just has a storage account here, and you can see that that's all that's within this particular resource group. And then I have my other resource group here that has multiple resources in it. So I have my resources segmented based on my resource group, based on my specific need. And that's what Resource Manager will do for me. And again, like I said, that's through the Azure portal that I was showing that, but that's all within Resource Manager and the portal are really one and the same. But we can manage those resources and manage that Resource Manager through running PowerShell scripts or CLI scripts or even REST APIs through our services. So keep those types of managing of resources in mind. Azure subscriptions, important to just understand the different boundaries here in terms of the Azure accounts and being able to separate based on different subscription levels and then also billing levels as well, all the way down to the Azure subscription. I have multiple subscriptions on my account that I can utilize for different things within my different demo environments, and that's really what it comes down to. Each one has a different billing profile. Not a whole lot to need to know about those subscriptions besides that necessarily. And then to take that a step further, below those subscriptions is then we have our management groups. I have all of my resource groups and everything. I have a different directory for each of those resources and for each of those subscriptions within that management group subscription. That's really a directory, and then I have my resource group and my resources under there, as I showed, is really how we manage our services there. And as I showed, I have in my one subscription or that we were looking at, I have a resource group that has like a virtual machine and a virtual network and a storage account. And then I have another one that only had a storage account in it. So those that gives us that flexibility then. And I can create those based on, like I said, department or country, and we can pull information based on those resource groups and those subscriptions to understand what cost is being done. Understand that you have 10,000 different management groups that are supported in a single directory. So you got quite a bit of expansion capabilities there. So now we're going to take a look at some key workloads here, and I'm going to build out this slide here to kind of show things here a little bit in terms of what those workloads might look like. Then you can see, there is really, a full kind of almost periodic table of elements here that go into the Azure subscription. We have all of these capabilities here around compute and web access and mobile access, our media and content delivery. We're going to talk about each one of these in its own kind of realm as we go through this slide deck. What we're talking about here now is to a degree those infrastructure and those compute services, right? Where virtual machines and our containers, as well as some of our database and data capabilities here over here on the right under data. We won't in this particular presentation go into every single one of these pieces and these components, but just keep in mind that there is a whole wealth of capabilities and within the Azure environment that really in a 4-hour session or even an 8-hour class we can't go through in depth. There are a lot of other role-based exams that go into like analytics and IoT. There's a specialty specific around IoT development. There's security certifications now There's, developer certifications. These really kind of almost way Microsoft has been building out their role-based certifications really is getting down to almost creating different role-based certifications based on really each of these boxes to a degree. So let's talk about those core workload services. So these go around those virtual machines, app services, container services, kind of those key compute level services that we were talking about down in that bottom left, as well as app services, which was a little bit higher up there. But these all talk about those core compute services. And when we're talking about compute, we're really talking about that processing power of, disk, memory, really ultimately what you would think of in terms of if you're standing up buying a server, you're buying a desktop. That's really where the compute services start to, what you're purchasing without having to purchase that hardware. You're purchasing what you need to perform the duties of a server or a web application or a laptop computer without needing to actually purchase the physical hardware for it, and gives you that flexibility too to scale as you need it. So if you go with a 16 gigabytes of RAM virtual machine, you find that is not enough memory, or you go with only two virtual CPUs and feel you need 4, you can very easily upgrade that virtual machine without having to remove it and create a new one from scratch. So let's talk briefly about virtual machines and understand a virtual machine is, again, that's that virtual processor, memory, and storage. And we'll walk through actually what we'll do instead of going through and talking through a slide is we'll go back into the portal here and take a look. Now I already have a virtual machine that's created here, and we'll go to that here quick. Trying to follow along with the lag that I've got that you guys are having, so that I keep the pace of my dialogue consistent to what you all are seeing. You can see here in my virtual machine, I created a virtual machine here, and you can see the size here is actually, this would be the same as if you're looking for a desktop computer or a laptop computer, how many processors it has and what the size of the RAM is what the gigabits of memory is. Small machine that I just stood up quickly here this morning to show this. But what I could very easily do is I can resize this virtual machine here by going down here to size. And if I feel, okay, this is the virtual machine I have right now, and let me catch that up. You can see that it highlights the virtual machine that I have, and say I want to upgrade that to a little bit larger machine. I need 8 CPUs and 32 gigabytes of RAM. I can very easily click this and select then that resize button here down at the bottom to resize that virtual machine. Now, one of the things that you can see if you scroll over to the right is that it shows you what your cost is. So you can see here, I am currently using a virtual machine. I think this is the one here that's $30.37 per month, and I would be increasing this to $280.32 a month if I was to increase to this virtual machine. But very easily resize this virtual machine. It changes nothing on that virtual machine. All it does is it stops it and restarts it, so you gotta know that you're going to be down for a moment. But it moves the image that you put on that virtual machine, everything that you have on there, the application and everything that's running on it, gets placed on that new virtual machine that's created. So very easy. This is really the benefit, what we're talking about when we're talking about elasticity and ability to make changes rapidly based on need. If I had a server or a a desktop or a computer within my own environment, and I've decided that that's not adequate, and maybe I can or cannot upgrade the RAM and processors by buying another processor and RAM, but it's definitely going to take longer to go down to the computer store, get that equipment, get what's needed, and then physically go in, turn that machine off, and make those changes, and then hope that it handles that capacity properly and turns back on properly. We very easily can do this within seconds here in the Azure portal. And then as well as if we just needed a new virtual machine, I could go into my resource group, go to the marketplace, and give a moment for the lag to take effect here and everybody to see what I'm seeing. And when I'm in the marketplace here, you may have noticed that I was using a Linux server again. I was trying to save some cost by utilizing a Linux operating system rather than renting a Windows one. But we'll do here a Windows server. I can put it in a different resource group if I want. I can create a new resource group, or I'll just put it in the one that I had. I can give it a name. I have my selection on my region. I'll leave it in East US. If I want availability zones, I can do that. I can set up those here. Again, here are all my images. You can see the different images that you can select. Are different sizes. Again, that's using the size that I just selected. If I click down, it'll see some that are recommended or that I recently used as well. I'll just pick this D series one for this. Create my username and password. If I wanted to allow this to be remotely accessed, I can do that as well at this time. We can then step through the different capabilities here. We can attach storage for data disks. We can change the networking. It's going to default that if necessary. I have a virtual network already created. It's going to default that. It's going to give a public IP address. It gives me a chance to opt out of leaving RDP open again if I wanted to. I'm going to leave that open for now. It takes me into my management capabilities here. Different disaster recovery and backup I could set up at this time. So a lot of things that I can do at the onset of creating my app, my servers. Extensions, I can put extensions on here if I want to put semantic or Microsoft anti-malware extension. I can do that as well. Tags we'll talk about later in terms of governance, but we can set up different tags by department or and just really kind of set up a way to understand what resources are being used for is really what tags would be used for. And then we can just review and create. And this should validate and pass. Again, it gives me lots of warnings about this RDP port that's open. And full transparency, it tells me also what this is going to cost per hour when I deploy it as well. So lots of things that I can do here within my environment, and then I can just click create and it's ready to go. So that's how really a virtual machine, and what we have then is we have a virtual machine with an operating system, with compute, memory, and storage that I can really install and do whatever I want with. I can go in and execute, put whatever files, just like it's my computer, but it's my requirement and responsibility then to maintain that, make sure it's patched correctly and all of those things. App services takes that a step further, where now we're utilizing platform services. So now we're, instead of a resource that where we have access to an operating system, now they cannot now they do not need to we can create these app services and create applications based on the code, whether it's .NET or Java or Python. We can develop our applications that run on those platforms and place those in containers directly on these compute services. And so it gives us, again, much more flexibility. We know that the operating system, whether Windows or Linux, is running the most recent platform of each, so we can continue on and continue to understand and continue to just manage our actual app and our application that's running in that service, rather than worrying about the compute services. And there's a lot of different capabilities and flexibility around that as well. And I already created an app service plan on my subscription, and we can go in here and kind of look at my app service plan here. If I want to look at what we have here and what our capabilities are within our app service plan, if I wanted to increase this and do something else in terms of my apps, you can see I'm on the free tier. So there's a lot of different free services within Azure, where you can go in and you can create and you can utilize those services within Azure without it costing anything. We can develop very easily within by using the free tier for an application. So we don't have to worry about what costs going to be at first. We only have 60 minutes a day of compute resources. So if we're only going to work on it for that amount of time, that's fine. If we've only got an hour a day earmarked for our developers to work on this particular application, we can use the free tier. If you need a little bit more, we can use this developer tier, which is only still $9.50 per month. That gives us 4 hours a day, gives us half a day to work on this. So we have those capabilities here to very inexpensively develop applications without having to really pay for any compute resources. And then as we get these into production, we can go over to other app service tiers that allow us to do different things, that give us a lot more memory, a lot more capabilities within these services, to perform properly for our organization, and some of the things that you might need, as well as, you can see here, we've got auto scale. If we have, again, a web application that's only running at a certain degree, certain level for 9 months out of the year, but we need to scale up or scale out on the amount of resources that we need for the Christmas season, we can use these production level services for that. Custom domains, if we want to have our own website be directed into this app service, other than just the free tier doesn't give you the custom domain. It's just it gives you what since I called this DN Cloud App Service, it's going to be DN Cloud App Service at webappservice.microsoft.com or something like that. So keep that in mind. Different app service plan levels have different things, and when you go from one subscription level to another, that's called scaling up. When you're adding more compute power, you're scaling out, or you're scaling in. So keep an understand, and you might get a question around scaling up an app service plan means changing what that subscription is. Scaling in and scaling out is needing more compute resources. Keep that in mind. Container services is, again, this is really compute services, again, obscured from the actual virtual machines and the actual compute, the operating systems. We're now running platform services. We're running compute services. One of the nice things about containers is they're lightweight environments, so you can run multiple applications in multiple containers utilizing the same compute resources in a very dynamic manner. And container instances is generally for, for a single kind of application in a single virtual machine, and then Kubernetes provides like a very high level, large volume of orchestration for container utilization across applications. So very dynamically, you purchase your services to have a certain level of compute, and you can run multiple containers within there and do run multiple applications that may need be differently in terms of where and when they might need those applications. And I'm not going to go through that particular walkthrough because it takes a while for a container service to deploy. But ultimately, that just to understand what you need to know around container services is that they are that lightweight way to perform and to utilize compute services really for applications. And really, when you do an app services work very tightly with, and like web apps run generally in containers now. Virtual desktop, where we're talking about virtual machines, we're talking usually about servers. Windows Virtual Desktop is desktop applications. So running Windows 10 in a cloud environment would utilize Windows Virtual Desktop. And to run those virtual desktop environments, you need servers in the background that are hosting those resources and providing what's called host pools to accommodate what is needed in terms of how many users you have within your environment that are going to use virtual desktops. Virtual desktops are very helpful in highly secure environments where you don't want your data and your applications running on a personal computer or a laptop that might get stolen. If they're accessing through a desktop type image, a virtual desktop image, once that logs out, all of that data is still in the data center, and if that device gets stolen, nobody has access to it. It's also very helpful in environments where you might have multiple shifts utilizing the same hardware. A good example there is a nurse's station, or even in an educational setting, in like a computer lab where somebody can log in utilizing their student username and password. They get their own desktop image that shows where they were working previously, has access to their particular files and everything, and then when they log out, that image is closed down, and the next person that comes in that logs in gets their own personalization, their own personalized image for what apps and what files they have access to, without having to have that all sit on a specific device within a computer room. Gives a lot of flexibility too if you're moving from room to room, or you're in a different computer lab than you were previously. You log in and you still get what you had on that previous device. You might not always get the same device every time you go into a computer lab, and this virtual desktop capabilities provide that to you. And from a networking service perspective, we have multiple things to think about here. The building block within Azure Network Services is the virtual network, or the VNet, which ultimately is your component within the within that resource group, or within those resources, how they're connected. And what the IP address that they're ultimately utilized to connect to. Virtual networks can be connected to on-premises on-premises networks, as well as and we can connect to other virtual networks by peering those networks together and creating more of a flat environment as well. Virtual private network gateways, or VPNs, provide that secure connection from an Azure environment to say an on-premises location or another network location. And then ExpressRoute is more of a dedicated connection, as stated when we were talking about hybrid networks. You might have a dedicated connection from Azure to your on-premises network to provide a higher level of security. There's a level of security with virtual private network gateways, or VPNs. Those still go over a secure transmission, but they aren't private networks per se. And I do have a virtual network created right now. If we go into my resource group again, and I'll allow time for that to lag, for the lag to take place. And I have my virtual network here. And you can see my virtual network is created. I have my virtual network address space up here. And because I created two virtual machines, the one Linux virtual machine as well as the Windows virtual machine, you can see that those virtual machines are located here within my virtual network. So those are my resources that I have within my virtual network. I can very easily peer this with another virtual network right here. I don't have another virtual network running right now. I can create a firewall within here. I can do additional security capabilities. I can create those private endpoints. So again, and can also tie that VPN gateway. I can create a VPN gateway within my resource group that connects this virtual network to, say, an on-premises network as well. So, but this is really ultimately, you have your virtual network. It's going to be very similar if you're familiar with VLANs on a layer 3-4 switch. We have our VLANs that we segment our resources, whether it's voice or data or web, segment our traffic. We can do the same thing with VNets within the Azure environment. And Azure storage, as we talk about storage, we have multiple types of storage capabilities within the Azure environment. We have disk storage, which I went through kind of quickly when we were talking about our virtual machine. These are generally managed disks that very similar to like your CD drive, your drive letters on your laptop or desktop. That's really what the disk storage is. That's our managed disks. There's also a operating system disk that goes when you create a virtual machine. Containers and Azure Files both fall into Azure storage accounts. The blob storage is unstructured data, which is very similar to like OneDrive is really considered blob storage or container storage, where it utilizes the metadata of your files to create that file structure, create what looks like that file structure, but really it's all just really a dump of files, even though we can put folders in there. And then Azure Files is much more like a file server type environment, that server message block protocol, or SMB 3.0 protocol that you utilize for mapping drives from a network share to a user's desktop. You can do the same thing with Azure Files as well. And those both fall into a storage account, and I can show you that in a moment here, but let's talk about the hot and cold, the different access tiers that are within a storage account. And there are generally 3 storage tiers that go within the life cycle of our storage, and it's hot, cool, and archive. Hot is what you're utilizing on a day-to-day basis. It's what your OneDrive is. Cool storage is that isn't accessed for like 30 days or so. So if it's sitting around for more than 30 days, it can go to a cool account. And then archive is anything older than one that hasn't been touched for 180 days can go to archive. there's more latency around getting back archived storage. There's some limitations on how much you can access cool storage, but from a management of your costs, storage becomes a very large and increasingly growing cost within your Azure resources, because we're putting more and more data into our environments every day. So having a good lifecycle management in our storage account for moving data from hot to cool to archive is very helpful. And I do have a storage account created here, which is the next walkthrough that I wanted to show. So give me a second and I'll bring that over, and we'll wait for the lag to catch up here. But when we get into the storage account, you'll notice that we have our containers and our files right within the overview of our storage account. We also have tables and queues, which we won't talk about a whole lot within this environment. And within the different capabilities, especially within the containers or blobs, is this lifecycle management. And we can create here our rules for lifecycle management based on how that's being used, and we can move our data then very easily based on this rule from hot to cool to archive, and then to delete it. Say it's your storage file that has your tax records for the United States. We need to keep those for 7 years. We don't need to necessarily have them in hot storage and paying for that. We can move them, have them in hot storage during tax time. Once we've submitted our taxes, move them to cool storage, wait 180 days, make sure we don't get audited yet, move them to archive after 180 days, and then hold on to them for 7 years, and then delete them automatically. So we know we know after 7 years in the United States, we don't have to hold on to our tax records anymore. We can purge those from our storage account, from our archive account, and eliminate those from being available. So, so those are some things that we can do in terms of creating that life cycle management. And again, we have in the storage account all of the as well those file shares, where we have the ability also within file shares to map those drives and create a file share and share those files, share and give everybody a map drive to collaborate with. And so very similar to what you would do in terms of a file server. So those are the key things around that. Database services within Azure. The key database services to think about for this exam and understand are Cosmos database, Azure SQL database, Azure database for MySQL, and Azure database for PostgreSQL. Way to determine what is what within here is if you ever see a globally distributed a question asking for a globally distributed database service, Cosmos DB is always the one. SQL database, obviously, a lot of understanding and a lot of need to know the relational, that this is a relational database as a service. This is based on Microsoft SQL. So if you need Microsoft SQL, this is the database service to utilize. Again, then we have MySQL and PostgreSQL as specific around those open source relational database type applications. To understand our SQL, what the SQL database is, there are 3 flavors of Azure SQL database, but in the context of this course, we're talking Azure SQL Managed Instance as the key one here. Again, this is a platform-based service. We have capabilities here for hybrid benefit if we have our own SQL licensing through enterprise agreements. but key thing around this is you don't have to manage the operating system. This is a platform-based service. So and database people that work in databases are very happy about SQL Managed Instance, because SQL Managed Instance, you no longer have to patch the databases and worry about putting a patch out and it breaking your database. Microsoft is going to have the most recent stable version of SQL Server always running on this managed instance. So you don't have to worry about anymore these breaking your database coming offline because your database broke. Because you did something to SQL Server, you changed a setting on SQL Server. You don't have that access to it, so you can't break it anymore. And that's really one of the great benefits to Azure, is moving SQL databases to the Azure environment, especially because from a cost perspective as well, being that Microsoft owns obviously SQL, there's some cost benefits to running a SQL server within Azure SQL Managed Instance versus other cloud providers as well. We've gone through and looked at the marketplace a little bit. When I was creating a virtual machine, but if I was to go to create a resource, when you go to create a resource within Azure, creating a resource within Azure, it takes you to the marketplace. And the marketplace is not just Azure services. There's multiple services within here. If I was to go down to security, for example, it didn't take me to security. If I was to go to security here, this is a really good example. There are a lot of different security services. Let me let it catch up here. There are a lot of different security services from other third parties that are within the marketplace. It's not just Azure services. Microsoft allows their partners to put services within the Azure marketplace and sell those services as co-sell ready type services within the marketplace. There might be professional services and things that are involved in purchasing those services or additional licensing, but it's generally pretty transparent when you do it on what the process is to utilize those. But keep in mind, the marketplace is the place to purchase your services, get all your Azure services as well as open source and other application developer tools, with over, as the slide says, over 10,000 listings. So let's go to our next knowledge check here. So here we want to think about what the term is that best describes a one or more data centers equipped with independent power, cooling, and networking as an isolation boundary. And if one of them goes down, the others continue to work. And our choices here are availability sets, availability zones, or regional availability. And this is really the definition of an availability zone, because that is one, as I explained, one or more data centers that with separate utilities coming into them. All right. Suppose you have an existing application running local on your server. You need additional capacity. Which compute option would likely give you the quickest route to get your application running? So you don't want to upgrade your on-premises equipment. What is the best option here? Because essentially what you're doing is you're handling a lift and shift type environment. This is where a virtual machine takes place. You have full control over the virtual machine setup. You can do all the configurations, and you can take that existing application and just lift it with little or no charge and install it on that virtual machine. There might be a potential use case for you to use app services in this model, but this is really talking quick. I've already got an application that I know runs on a virtual machine that is that's Windows based. This version of Windows, I can just go and execute it on another virtual machine. I just need more capacity. I'll stand up this virtual machine rather than ordering new hardware. Next question, which service offers a distributed network of servers that can efficiently deliver web content to users that focus on minimizing latency? We didn't talk about this a whole lot in terms of the networking piece, but this is a content delivery network. So a content delivery network is another way to eliminate latency by, if you think about a service like Netflix. Netflix is a content delivery network. It caches where you're at and brings that video that you have requested and downloads it to a regionally local network point, and then provide you with your content and eliminates latency. When you're done viewing it, somebody else that's within your area might be able to view it as well, and it saves latency time for them. After a certain amount of time, it's removed then completely from your from that networking area. It's just cached for a certain amount of time, and then it's removed. So that gets us through objective 2. Again, we're moving fast, so we're not covering all of the knowledge check. Again, you'll get this slide deck. It's got those links to the knowledge check. Feel free to select those and to take those practice questions, as well as review the practice questions that we've been going through. So, this particular module, we covered things around regions and geographies, the different tools, as well as the core services of compute, networking, storage, and databases, and how that all ties into the marketplace. We'll go into some additional core services here in objective 3 before we take our first break. So bear with me. We're 2/3 of the way to break time, and we're going to now cover some of those more advanced level solutions in this particular objective. So we're going to talk at a high level again now about the services like the Internet of Things and Azure Sphere. We'll talk about Synapse Analytics, and big data type solutions, as well as AI and machine learning at a very high level. We have a AI fundamentals recording that we did a few weeks ago, as well as part of this platform, as well as Thursday I'll actually be doing this similar exam cram around AI fundamentals. But we'll talk about those services at a high level, and then again, as I said previously, we're going to hit a little bit more detail around those management tools and some of those monitoring and advisory tools that go into the creation of resources, as well as the analysis of what's going on within our environment that we discussed as a benefit of our cloud tools. So let's go back to our periodic table of services within Azure here. And when we talk about, and what we're talking about within this particular section here is we're talking about here in the middle section of the analytics and IoT. We'll discuss some more around the data side with some of the large data services that we haven't really gotten into yet. As well as, again, some of those tools for managing our services within Azure. So first and foremost is to talk about some of the services that go around the Internet of Things within the Azure environment. We have what really Internet of Things is really to kind of put it in perspective. When we talk about Internet of Things, we're talking about all of those services that are connected to device, all those devices that are connected, right? We're talking about our personal assistants. If we've got an Echo device or Cortana, some sort of utilizing a Fire TV. Those are all those devices that are connected to the internet and relaying information for data analysis. Even our smartphones, to a degree, is an IoT device. So all that information that's coming in, and in a business environment, a good example of that is utilizing having connected our machining in our plants connected, our thermostats, all of those things that are connected, our smart lights, all of those things that make up smart businesses and smart homes are all IoT devices. And those IoT devices are all gathering information and relaying information somewhere. And within that, how do we then utilize that information for good? How do we provide some level of data analysis around all that? And Microsoft within Azure has a whole bunch of IoT services that can be utilized. There's IoT Central, which is that solution that connects and manages all of those assets at a very large scale. There's IoT Hub, which is again another managed service as a centralized hub for communication. So if you have a device, say a Raspberry Pi, a device connected to a Raspberry Pi for some, that needs updates, IoT Hub can provide that dual communication. So it's not only gathering information that's coming in from that device, it's also sending updates out to that Raspberry Pi for changes in the application, in what information we want to gather, or it can do even operating system upgrades and updates and things like that we need to do. So that's really what IoT Hub does. Azure Sphere provides those security capabilities for those devices and that built-in communications within that. So it brings it all together from that standpoint. So that's really kind of the main things around those three pieces there. Next piece to think about, and next level of solutions to think about is when we're talking about data and analytics, and we're talking, taking it a step further from just a database level of data to, we're talking now large amounts of data, obviously, Internet of Things, IoT devices really are creating large amounts of data that we need to work with, and we need to analyze, and we need to determine how to utilize. And that's what these big data and analytics services do, such as Azure Synapse Analytics, which provides that a large cloud-based data warehouse for limitless analytics services. Azure HD Insight is a fully managed open source analytics platform. So, if you're utilizing analytics, if you're utilizing like HD Insights already, or Hadoop falls into that utilization, you can use HD Insight in there. Azure Synapse Analytics is built in that relational database type SQL type environment. It's just at a large scale. And then Azure Databricks, again, is another open source based on Apache Spark. So another analytics-based service. So really, all of these are analytics-based services based on your specific need. If you have something that's in Spark that you're already utilizing Apache Spark, you would probably move to Databricks. If you're utilizing, inherent Microsoft and SQL type database type services, you potentially would use Synapse Analytics. if you're utilizing like Hadoop and like open source HD Insight, you can really easily tie that into Azure's HD Insight engine as well. And the three key things to talk about in terms of artificial intelligence and machine learning is really machine learning, cognitive services, and bot services. And those are the three things to really worry about here when we're talking about our capabilities within AI and ML in the Azure environment as it pertains to the fundamentals exam. Azure Machine Learning is the cloud-based way to develop and train and do different machine learning models. Obviously, cognitive services really handles all of that speech, that sight, the hearing, your computer vision, recognizing who somebody is on a picture and taking a text message and speaking it to you, or speaking into your phone and the text goes out of that. That's really all cognitive services. And then bot service, everybody has probably interacted with a bot in one way or another, where we are communicating with our on a chat to really not a person. It's really usually used as your front end customer service, where it's gathering a level of information before you go into actually talking to a live human being. Just gathering that information, knowing which direction to send that information in, is really what we're talking about here in terms of bot services. And I told you we would be coming back to serverless computing again, and we are here with the Azure Functions and the Azure Logic Apps. And again, Azure Functions are event-based code, very at its foundation. It's code that is going to run based on a specific event taking place, whether that and that could be tied into like an IoT event or something that you set up, and that's going to execute execute something. There's no real infrastructure that we are utilizing or even need to know about in terms of Azure Functions. They're tied a little bit to app services and to the amount of calls to that function is usually how you're billed. So there's really, you don't even know what compute resources you're even using for an Azure function. Same thing with Azure Logic Apps is actually a way to automate and orchestrate tasks in more of a visual graphic like workflow. So like I said, if you want to know how Logic Apps works, it works very similarly to this if this then that, where you say if Microsoft is mentioned in Twitter, I want to receive an email on that based on that Twitter that tweet based on that Twitter post. That's really how Logic Apps works. It sees some trigger and it goes through some workflow. It can be a lot more intricate than the example I gave, but I want to just kind of paint a picture there. Functions is very similar to that, but works more. You have to know a little bit more developer code than you do Logic Apps. Logic Apps, very easy designer. If anybody's ever designed anything in terms of like a Power App or anything like that, the designer is very similar to that interface. And then the last part of this particular section is talking about some of the developer tools to understand within the Azure environment, and just some things from a high level to understand is Azure DevOps is a way to manage pipelines. GitHub does very similar. GitHub and GitHub Actions do very similar to Azure DevOps, and Microsoft's actually integrating a lot of GitHub since they bought GitHub into DevOps in terms of the deployment. There isn't as much in terms of Kanban boards and managing kind of backlog backlog boards that you have in terms of DevOps. That's kind of the key differentiator there. But GitHub is open source. You have the ability to share code and test code of others and make suggestions within GitHub. GitHub Actions takes that a step further of deploying and creating that workflow as well. And then DevTest Labs is a way to just create and run different a lab environment very quickly and control your costs from that standpoint. Just a very quick way to just exactly do what it says. Dev test an environment without putting it into your actual production type environment. And you can do a very similar thing by just putting it in a different resource group, but this is again just a way to dev test and very quickly spin up resources. So these are some developer services just to think about and just to understand at a high level. And then let's talk about some different management tools. And we had the graphic earlier that kind of showed how everything flowed into our subscriptions and our resource manager. And this just talks about it again and kind of shows here we have our Azure portal, which I've been showing things in. Azure portal's tied very tightly. Really, resource manager is part of really the Azure portal. It's really just the GUI interface of Azure Resource Manager. There's an Azure mobile app that does very similar to what the Azure portal does and what the web interface does. You can do many of the same things within the web app. There are some limitations to what you can do on the web app, but one of the key things that you can do is if you're just doing testing and you forget to stop a virtual machine at the end of the night and you don't want to incur additional costs while you're not working on it, you can do that on the Azure web app. Azure PowerShell and command line interface are two different ways to deploy resources utilizing code to the resource into the resource manager. So if you have a template or a script that you want to write that you've written to create a virtual machine, you can deploy that using Azure PowerShell or command line interface, or utilizing Visual Studio to deploy either one of those. There's extensions that you can do either of those depending on what way you're most comfortable in script writing. Cloud Shell, Azure Cloud Shell's built within the Azure portal and within the web GUI for doing the same thing. You can run really shorter, quicker commands of PowerShell or CLI within Azure Cloud Shell. So if you just need to do a quick update of something, you can do that there. It will not deploy long lines of code or your resources to a large that are referencing multiple parameters and things like that a PowerShell script can do, but it'll do it at a smaller level. And then REST APIs are really that connection between our services, our application, and calling those resources through a application interface rather than calling it and deploying it and deploying those resources based on that connection and based on those resource connections. A little bit more complex in terms of REST APIs than the other. Each of these I've kind of gone through in terms of level of complexity is how I kind of communicated those. Azure Advisor is another piece here where Microsoft actually provides you with capabilities to and recommendations on how to make a more reliable, secure, and higher performance environment, how to manage costs, and where you're at really in terms of overall baseline in terms of how good your environment works and how good your environment's running. And that's what Azure Advisor does. It's a free service that you get within when you subscribe to Azure services. It will tell you and give you this give you these recommendations based on these areas, these 5 areas here listed on the slide. So understand that these are, understand what those 5 areas are, and keep that in mind. Azure Monitor, next up to talk about is Azure Monitor. Everything is tied, every service within Azure is tied to Azure Monitor in terms of what it gives you in terms of events and metrics for your services, and all that telemetry, everything that's coming in, everything that's happening in terms of we can turn on application insights and log analytics, all fall into there. We can customize dashboards around what's taking place in our environment. Like I said, from a metric standpoint, in terms of performance of our virtual machines and our databases, all of our compute services, to events that are taking place, from security events or just general activity on our resources. That all is tied into every piece of the Azure environment, as well as you can deploy agents on-premises virtual machines and networks, such as Network Watcher, and deploy those in on-premises environments to also gather that information and pull that all into one dashboard to understand what's going on in your overall hybrid infrastructure. Azure Service Health is where we can go to see if any issues are taking place within the Azure environment. So this will allow us to understand if we're having problems with our resources. We can very easily go into Azure Service Health and verify that it isn't a problem. If I'm having problems with my storage, for example, on the slide, I can see if there was an outage that took place within a region that I'm running resources in that may have caused some level of latency or some level of issue within there, and I can view what that problem was and do some level of reconnaissance around what's taking place within the Azure environment that might be affecting the performance of my environment. So Azure Service Health is really that dashboard to go to and to find whether there's any service issues prior to opening up a support call or going through a whole lot of troubleshooting on your own end to find out that maybe it's an overall regional or global Azure problem. And just to continue on real quick from that, there's detailed statuses that Microsoft provides in Azure Health that helps to show what regions are effective and what's going on, and when the next when it might be resolved, when the next update's going to take place, and things like that. The last thing to cover here is Resource Manager templates. We've talked about Azure Resource Manager. We talked about our services and how we can deploy our services within the Azure environment. And when we're talking about deploying resources, we generally, from a PowerShell standpoint, we'll utilize these templates, which is really the declarative language that Microsoft's looking for in terms of what resources are. And it allows us, these templates allow us then to recreate and deploy consistent infrastructure and have repeatable results. We can utilize automation accounts for orchestrating the deployment of services, and it helps us maintain a baseline and understand how our resources are defined as well. We can go in to any of our resources, and I'll do that quick before we get to the knowledge check here. We're running okay on time for right now, so let me go in to say, actually I'll go into my resource group, and actually if I want to go, I can go down to automation and go to my template. And if I actually want to export, I can actually export this template with everything that's within my resource group, and what is deployed is all within here. And you can scroll down and you can see my network services group, my log analytics, my security insights, all my variables in terms of location, and I can export this. And if I want to duplicate this, say in West US, I can export this whole template. I can download it or add it to my library, make some changes in terms of, in terms of some of the parameters, in terms of, my location, make it West US and deploy it in West US and create identical. Or if I want to do it in, say, East Europe for a new European division that I've created, I can create the exact same resources there within Europe with very limited additional build. I don't have to recreate the wheel and recreate all of this language here. I may have to make some changes. You can see there's some resources within my template that can't be deployed in that template, so I can check those errors. I can adjust my ARM template accordingly. So let's do a couple quick checks here as we come on to our break for this session. Your company has multiple web properties that a customer can reach you on. You would like to create a common set of code that each of them can use to create a lead in your customer database. Which service and app services would you use? So this is an interesting one. We could create an API app. So we don't go too deep into this, but understand that you have lots of capabilities within the app services. And since this is a customer service type application where we want to create that code, we can create then an API app that then is going to allow that code to work with like HTTP and HTTPS. So it's an API service app, a little different than like a web app or a mobile app. It's going to, from a web standpoint, allow you to communicate with people through that web app service. Next one, which service is not considered a feature of Azure serverless computing? So we've got machine learning, functions, logic apps, and event grid. Which one is not a feature, is not considered serverless computing? This one would be machine learning. Machine learning is actually not considered serverless. It actually runs in a app service type environment. So it does have that compute engine, generally utilizes some level of a container, again, very similarly to what we were talking about in terms of app services. It really is kind of that app service type use where you can actually when you create a machine learning model, machine learning service, you actually set up what processing power you need, which by definition takes it out of that serverless. When you create any of the other three, and I mentioned this with functions and logic apps, you really don't even know or mention what kind of compute services. And event grid's very similar to that as well. All right. This objective area, we covered all of those services and solutions. This kind of brings us to the end of this objective, and we talked about those services and solutions that make up our IoT, our big data, our analytics, and all of our development tools. Our Azure Resource Manager and our monitoring tools is really what we covered here. So we covered a whole bunch of our solutions. So when we come, we're going to take our break now. We're going to take 10 minutes. When we come back, the next three modules are really going to get deeper, are going to get into a little bit more different types. Not going to specifically talk about, specific services. Module 4 will a little bit because we're going to get into security. But 5 and 6 are going to really get into now. Once we have all these services in place, what do we do to protect those services? All right. So please, we'll have an announcement from Microsoft after the break around a special offer that is part of your attendance today. So please, it is it's 9 after right now, so let's say 10 after. Come back at 20 after, and we'll have an announcement following the break, and then we'll get into the next objective. Thank you very much. I'll see everybody back here in 10 minutes. All right, hopefully everybody's making their way back. We got 1 minute or a few seconds before I think the time will roll over to 20 past the hour. And there we go. So let me change my slide, let that refresh here, and I think we'll have Jeff from Microsoft provide a quick announcement here.
Yes. Hello, everyone, and thank you, Dwayne. I'm Jeff Johnson with Microsoft, and on behalf of Microsoft and our global exam delivery partner, Certiport, we're delighted to allow for and announce for all of you who are attending and participating in our webinar series, and particularly the Exam Cram, that we have an offer for you to take advantage of with a no-cost exam bundle, which will include a practice exam as well as a real exam voucher for you to sit for any of the fundamentals exams. So possibly ideally for your own AZ 900 exam that you're cramming for today or in this webinar, and you'll have an opportunity to pursue getting a no-cost voucher on behalf or from Microsoft for this. It's available between now and June 30th, 2021, while supplies last. So do take advantage if you're at all interested as soon as possible. And to claim the offer, there's instructions here on the slide, but you'll want to email direct to certfund or CERTFUND at Microsoft.com. Put in the subject line, certification is fundamental, and then request to receive the URL or the web page, and we'll send you a password. You'll then in turn go to the URL, the form, enter that password exactly and precisely as we provided it to you, and you'll be able to take advantage and apply at the form. You can see a slide view of the form here on this page, and input the password, and you'll be able to get advantage of that no-cost exam bundle. Again, it includes a practice test and any fundamentals exam voucher between now and taking the test between now and June 30th. Again, the supplies are limited, so if you're at all interested, if this is something that would be helpful to you in your pursuit of getting certified, please take advantage as soon as possible. The offer is live and available now. So with that, thanks everyone, and good luck to all of you on your skills acquisition in today's exam cram, and also in getting certified. Thank you on behalf of Microsoft. Dwayne, back over to you.
Thank you very much, Jeff. I appreciate that. And yeah, hopefully everybody takes advantage. That's a pretty good deal, especially having the two-use. The retake is a big one. Gives you that level of confidence that that you don't have as much weight on your shoulders when you go in the first time. I've found that I've used those retake exams, and I don't think I've used I think maybe once I've used the retake. It takes kind of that weight off your shoulder, though, that like when you pass it, it feels pretty good that, hey, I didn't have to use that retake. So all right, let's get into objective 4, and this one we're going to get now we've talked about all of those services. We've talked about really every service and solution that has to do with within the Azure environment at a high level. We're not going to talk about some security features and some security security concepts that all go into our full environment, and how we really protect some of those services and solutions that we talked about there in the first half of the session. So we're going to roll through these. This section is probably the next big section, and then the last two sections will go pretty quick. So when we talk about our service tools, we're going to talk about Security Center. We're going to talk about policy compliance, Azure Sentinel, Key Vault. We're going to talk about some of these services and Azure dedicated hosts. We had some questions back when we were talking about public and private services earlier on around, if can you run a private data center within, is there a way to put your own hardware or private hardware within Azure Data Center? There's not, but Azure dedicated hosts can help to provide that in one way or another. First thing we're going to talk about in terms of security is Azure Security Center, and Thing to know about Azure Security Center is very similar to what I said right before the break around Azure Advisor, and what Azure Advisor does in terms of cost recommendations as well as security and performance recommendations within our environment. What Azure Security Center does is it provides us with a security baseline that we can utilize for maintaining a level of security and policy compliance within our organization based on security baselines provided by Azure, or policy compliance if we're and regulatory compliance if necessary. So Azure Security Center is a very powerful tool to provide all those capabilities to us. And if we were to take kind of a look at some of these capabilities here, I can bring over and go to my own Azure Security Center and give a chance for everything to refresh here. And you can see when we get into my environment, the first thing that you kind of see is my percentage of my secure score. The thing with my secure score is that, hey, it's a demo environment. I stood a bunch of resources up this morning just to show in this class here today. So I didn't do a whole lot, and I haven't done a whole lot to improve my secure score, but I could go and click on improve my secure score and go to my subscription. And it's going to provide me with a list of recommendations that are going to help me to improve my score. The first one I always get on my demo environment is enabling multi-factor authentication. I don't have it enabled on all my resources, so it's not enforced across everything, so I have that there. Access and permissions, like I said, I don't have a whole lot of resources within my environment right now, so it's not giving me a whole lot of rich information here, but it could if I had more resources in here. And then the regulatory compliance piece here, if I have specific regulatory requirements within my environment, such as maybe PCI DSS or NIST or HIPAA in here, ISO 27001. I can see all these here and get recommendations on controls that'll make me compliant to those as well. So Azure Security Center is a very powerful tool to manage our policy compliance, our view potential alerts around threats. The secure score again is very helpful for maintaining and to assess our environment and how secure our environment is. And then those recommendations and everything really is how we can then maintain a level of resource hygiene and protection, and provides those tailored recommendations and that continuous assessment within our environment to protect our organization, and really becomes that centralized source that allows us to protect and put controls in place to protect our environment. And it works very closely with Azure Sentinel. And if you're not familiar with what a security information and event management system is, that's what Sentinel provides as a cloud-based service within the Azure environment for that SIEM solution, which generally is utilized within many security operations centers. And then that security automated response, or SOAR, is also that ability to automate and orchestrate investigation and response as well. So it does multiple things. It connects to the entire ecosystem of Microsoft, not just Azure resources, but Microsoft 365 resources, Azure Active Directory, as well as many third-party sources as well. Third-party security sources like Palo Alto, Cisco, can connect to CloudTrail and AWS, and we can pull all those events and all that information in terms of a full hybrid infrastructure into Azure Sentinel and utilize this as our base level for for security operations. Azure Key Vault is the next piece to discuss here, where we, within Azure Key Vault, in some organizations, we are required to keep a separation of duties from where keys are stored and keys are managed. By default, like with a storage account, for example, those are Microsoft managed keys, and the key rotation and everything. You can manage the key rotation, but Microsoft assigns those keys. You can push that to customer managed and then utilize Key Vault to separate those duties. And some requirements for certain compliances and things require that separation of duties within the utilization of key management systems, and Key Vault allows you to create that and to utilize that. And if you need to still separate that even further and get that out of Azure completely, we can manage those and tie hardware security modules, or HSMs, from our on-premises key storage into Azure Key Vault to manage our Azure resources as well. Another key thing as well is it does secrets management, which is helpful for API calls from one resource to another, and then certificate management. If anybody has ever been involved in a website certificate failing, and a website certificate, your website no longer, your SSL certificate no longer works. So from HTTPS, you can't get to your website anymore. So you can't use an encrypted channel anymore. You can only go on HTTP. Therefore, when that happens, your certificate has expired. You can manage that within Azure Key Vault, and Azure will through Key Vault renew those subscriptions those certificates automatically, so you never have to worry about when that expiration date is for all your website certificates. So very helpful real helpful utilization of Azure Key Vault there. I'm not going to walk through Azure Key Vault here today. There's not a whole lot necessarily to see there. I don't have much in the environment, but just keep in mind it's just a service in there to manage keys, secrets, and certificates. Dedicated hosts, again, as I stated earlier when we had the question about private resources within Azure, we can subscribe to dedicated hosts within the environment, where we are going to have private servers on a dedicated machine. Have some isolation at the server level for our resources, and allow us to have a higher level of control over maintenance, and can determine, okay, updates are going to happen at this time and all of that. This is not, again, the hardware is still provided, and the hardware is managed and maintained by Microsoft. It's really an IaaS, additional and different approach to IaaS, where you're, instead of shared compute resources, you're now on dedicated compute resources. So keep that in mind, that it's not a private network or private equipment that you have. So you're emulating private cloud, but you're still in a public environment. You're still in the public cloud ultimately, in terms of how shared responsibility goes. If you're looking at the shared responsibility structure, it's still IaaS in terms of that shared responsibility structure. It's just you're isolated. If you have highly regulated, highly secure requirements for your application, you can subscribe to the dedicated host to give you a further level of isolation in that environment. So now we're going to talk about the network connectivity piece, and talk about some more things around networking that we didn't talk about before when we were talking about VNets and VPNs and those types of connections. We're going to talk about first and foremost, understanding defense in depth, and to understand what we're talking about when we're talking about security and security baselines is how we're protecting our environment from a security standpoint, and really ultimately how we're doing that is we're protecting at different layers and at different levels, and what those services are based on what service we're subscribing to, and how we're protecting our data ultimately at the end. And so to take that a step further and to bring kind of the shared responsibility model into security, it's a little bit different than when we're talking about compute and infrastructure at its foundation, because the security is a little bit different here. Obviously, infrastructure as a service, there's really no difference. But when we get to platform and software as a service, there's some gray area in here in the application and network controls, because what Microsoft does is they put a level of network controls and security around the identity and directory infrastructure, the application and application security and insights. But it is for advanced level and higher level controls you might require as an organization. You have a level of responsibility there as well. So even though when we're talking about platform services, some of this when we talk about it at a service level, this ultimately falls into the customer requirement. Microsoft put some of that in place already, just as a baseline, because they need to protect their environment and protect their infrastructure, and they don't want certain things such as denial of service attacks to take place within their overall infrastructure, because if it affects you, the customer, one customer, it's going to affect many of the customers, because it's all coming across the same pipe. So keep that in mind. Same thing with software as a service. There's certain identity and directory infrastructure capabilities that Microsoft puts in place by default, such as multi-factor authentication for administrators. Those things. But to turn on other tools are your requirement. And one of those layered security tools is network security groups. And what network security groups do very similarly, they filter traffic based on ports and traffic rules that take place, for like IP addresses, port, and protocol. Very simple levels of inbound and outbound rules, rather than it doesn't do any kind of deep packet inspection that like a firewall would do, but it does. Network security groups are free. They are created when you create a virtual machine and with a network, to that network interface of that virtual machine, and those rules are then in place, and you can adjust those rules, virtual machine by virtual machine, as needed, to protect your environment, especially before especially from a development and early on standpoint. You can create these first level rules before you get to higher levels of your defense in depth strategy of protecting your network, with things like firewalls or web application firewalls and load balancers and things like that. It gives you that first layer of inbound and outbound protection. And then once you've gone a step further and you've built your application, you want to get a little bit more create another layer of protection, create more packet level inspection, more detailed rules about what traffic is allowed and denied within your environment. Then you can get to an Azure firewall, where we have a cloud-based firewall as a service that provides high availability, unrestricted scalability. It's as all services are. The logging's all built through Azure Monitor and utilizes Azure Monitor. And then we can also put to take that a step further and higher up the open source stack. in terms of the infrastructure, we can get to even application gateway and web application firewalls to take that a step further as well. So we can, it's this layer of additional traffic filtering rules that a network security group provides at a port, IP, and protocol level, to getting even just to the packet level and getting more granular and providing that, again, that additional layer of defense, really protecting that security perimeter. I mentioned when I was talking about the areas of services that Microsoft provides, even when we're doing platform services that might typically be our responsibility, but Microsoft provides some level of responsibility. When we're talking about distributed denial of service protection, or DDoS, that's one of those services that Microsoft provides us a basic tier for free, because they do not want their environment to be subject to a DDoS attack. So you get a basic service automatically enabled, and Microsoft protects all of their tenants from DDoS attacks, because it will, if one tenant gets attacked through a DDoS threat, then it's going to bog down probably all of their other tenants as well, unless they're on like a dedicated express route. But even so, it still could flood that network to a point where it's causing a problem. So they put that basic service on there. If you want to have more insight into the DDoS, the DDoS reporting, or making, doing any customization to the protection on different resources, then you'd need the standard service tier. So basic service is provided for free. Standard service needs additional tiering up of your service. And this kind of takes you now through that defense in depth and kind of reviews the services we've talked about and where they fall into each of these. So when we talk about our network solutions, in terms of, like I said, utilizing network security groups with Azure firewalls, we're providing that perimeter and network defense in depth, and really all even to compute, because the NSGs actually tie to the network interface of generally your virtual machines. At the perimeter, so we're protecting at that network and compute layer. Our perimeter layer, we're protecting with the DDoS and firewall as well, and like I said, the network is the network security group. So right there, we're protecting really three layers ultimately of our defense in depth, utilizing network security groups, firewalls, and DDoS protection. So let's hit a quick walkthrough here around the security pieces. So first question here is, which of the following is not a method for protecting internet-facing services from network attacks? So not a method of protecting internet-facing services from network attacks. Is it DDoS? Which one is it that is not protection from that? And if you go through any of the services we just talked about and talk about what's not on there, it's Azure Disk Encryption. Disk encryption is just encrypting and protecting our actual virtual machine. DDoS protects internet-facing services from DDoS. Web application firewalls protects from cross-site scripting, SQL injection type attacks. Firewalls provide that network level of packet inspection and traffic inspection to our virtual networks. And that really gets us through that objective. That objective is a very short objective because we already talked about like VNets and VLANs and things like that, which could really kind of be within that objective. But just understand, taking that defense in depth approach, and you might get a question around defense in depth and what that does. Key thing around that is just taking a multi-layered approach to protecting your resources, utilizing different services within Azure to protect. And now we're going to talk about identity governance, privacy, and compliance. So we'll get a little bit, and we'll revisit that question from earlier today about security level for education purposes when we talk about some levels of compliance here. So we're going to talk about identity services. We're going to start out here first. We're going to talk about governance features, which goes into role-based access control, resource locks, policies, things of that. We're going to talk through then different privacy and compliance and how compliance works within the Azure environment. So key thing around identity services when we're talking about identity, everything within the Azure environment runs through Azure Active Directory. So, and what Azure Active Directory does, and we need to think about and understand what the differences are between authentication and authorization. So when we authenticate, what we're doing is, and this goes all into the concept of identity and access management. When we authenticate, we're identifying ourselves and what service we want to access. We are providing, the authentication aspect is there's this little give and take there, right? The service then is requesting those access the credentials, our username, our password, whatever it is for our secure identity. And then what happens there after we've verified who we are, then we're authorized for what we have access to. So we, now we have what level and what I can get to based on what has been authorized to me in terms of what my role is and who I am within the organization. So that's really what identity and access management is in a nutshell. Understand what authorization, the difference between authorization and authentication. Authentication is just providing my identity. Authorization is what that identity gives me. Another layer to that then is multi-factor authentication, where we need to now provide a deeper level of verification to who I am, not just my password necessarily, but which is something I know, but one other form, generally either something I possess like a key or a code that has been given to me by an authenticator app, or something I am, such as biometrics, our fingerprint or facial recognition. And we're now verifying and we're authenticating utilizing these two of these three forms of identification and these elements to authenticate before we are authorized to access anything. Azure Active Directory is Microsoft's cloud-based identity and access management service. So when we're talking about authentication and authorization within the Azure environment, or even Microsoft 365 or Dynamics 365 or any of that, we're talking about Azure Active Directory. And so Azure Active Directory provides that authentication. It has single sign-on capabilities to other cloud services, or we can actually connect to on-premises environments for single sign-on to on-premises resources using Azure Active Directory Connect. We have application management. We can put application proxies on our on-premises applications and put them into to authenticate and authorize within Azure Active Directory. We also have business-to-business and business-to-customer type identity services. Business-to-business, where somebody else, you have a partner company that's on Azure Active Directory as well. We can utilize we can invite their organization into our Azure Active Directory in a business-to-business relationship, and then they can use their own licenses in our environment, and we can give them access because they're on our tenant, and we can collaborate on different different resources. Business to customer, if you've gone into a website and it has given you the option to log in using your Facebook account or your Microsoft account or your LinkedIn account. That's a business to custom consumer type identity service. You don't have to create a new username and password. They've federated that identity to one of those other services, and you can connect those that way as well as device management. So like Intune services, mobile device management and protection, all ties into that Azure Active Directory environment as well. Another level of management and protection is within conditional access. So we have the capability within conditional access is a secondary advanced layer of security and protection to take kind of a trigger level signal type approach based on somebody's device and their compliance on that device, who that user is and where they're located, what application they're trying to access, or whether there's a certain risk level based on that user, some sort of anomaly that we have noticed within our environment. Those all then can trigger trigger what takes place and what is enforced to give them authorization to what they're trying to access. So it may be something that they are allowed to access on a regular basis, but there's some signal that something just isn't right with this user. So maybe we had this user logged in. Their activity shows that they logged in from Michigan, and then 15 minutes later they're logging in from the UK and trying to access our main business application with all of our financial information on it, or our HR application with all our user information. It flags that and then could block access if we feel that that it's that the anomaly is concerning enough that we're just not going to allow them through, or we could require them to re-authenticate with multi-factor authentication to verify they are who they say they are. And it all goes into what's called a zero trust model, where we're making sure that when somebody is accessing information, especially sensitive information, that we're making sure that we're re-verifying constantly, because we want to make sure that people are who they say they are, and that we're not leaving ourselves exposed to potential vulnerabilities and potential threats that might take place with users that have maybe been gone through some level of phishing attack, or there's been a dictionary attack, somebody's password's been stolen, that has allowed somebody to at least use their username and password to get one step, and we need to verify a step further, and then that conditional access to require MFA could block a potential attacker from getting any further. So let's talk about some governance methodologies, such as role-based access control, resource locks. We talked about tagging a little bit, policy blueprints, and cloud adoption frameworks. So we're going to talk about quite a few little items here in this particular domain, but these are all ones to just kind of understand at a high level of what they are, type understanding when you're thinking about the test. So key thing around role-based access control is probably the one to understand the deepest is to understand what it is, and it ultimately is assigning particular roles based on who somebody is, and getting really fine-grained in terms of what the duties are going to be of this user, and what their role is, and what resources they're going to have access to, all the way down, maybe at the resource group level, or all the way down to the specific, storage account, virtual machine, database level. We can control that access through Azure Active Directory, and control that level of access control, and based on role, and we can get really granular. And there's many different many built-in roles that you can create, that you have, or you can create custom roles if somebody has multiple duties within your organization. But the ultimate thing is role-based access control. The key thing is to segregate those duties and make sure that people only have access. It's the principle of least privilege is what we're doing here. We're making sure that users only require, only have access to what they're required to do for their to perform their daily tasks. We don't want them to have elevated rights, because if their identity gets compromised, those elevated rights could compromise and create a threat to the organization. What resource locks do is they can protect our resources from being modified accidentally or deleted accidentally. They're pretty simple from that standpoint, where you can lock at the subscription, resource group, or individual resource levels. But there's really two different settings within resource locks. There's the delete setting, which is actually cannot delete setting, and then there's the read only setting. So you can go into a resource and say, okay, I don't want anybody to modify this virtual machine. I don't want them to add resources to it or make any changes to this virtual machine. I can put that in read-only mode. I can't do any updates. I can't remove it. I can only look and see what it is. If I do not delete is, okay, we can make modifications. We can change that that resource, but we can't delete it. We don't want somebody deleting this. This is our main application running on this virtual machine. We don't want to allow anybody to delete it. So we can do that for like our business critical virtual machines. Make sure that those that does not take place. Tags, as I stated when I was going through creating a virtual machine, what we can do here is we can add metadata to our resources, and we can organize our resources in certain in a taxonomy based on department or owner or cost center and then we can use that for billing information. So so if we want to make sure that this particular resource group is tagged to, say, human resources or to engineering, we can put tags on on that resource group and on those resources, and then we can run in our cost and billing center. We can run reports based on those tags and filter on those tags to say, okay, you owe this amount on these resources for this month. What Azure Policy does is this enforces, and we talked about Azure Security Center. Azure Security Center works very tightly with Azure Policy because it helps us enforce our standards. So when Azure Security Center gets turned on, there's a policy specifically for Azure Security Center. When you set up certain compliance controls and everything, that pushes a policy initiative into Azure Policy as well. And we have built-in policies and initiatives that define how we're going to manage our storage, our networking, our compute, our cost. It can help with providing governance, not just in a security standpoint, like I'm talking about with Azure Security Center, but from a cost standpoint as well. We can set up a policy that we are only going to utilize these 5 virtual machine image types, so that we avoid somebody turning on a virtual machine that's $2,000 a month. We can set that to manage our cost and do a lot better job, do a more predictive job in what our costs are going to be a month, because we know they're not going to exceed a certain amount because we've made sure that certain virtual machines can't be turned on. From a governance standpoint, we can set certain resource groups can only have resources deployed in certain regions. So we can make sure that this U.S. resource group only has the region location set for the U.S. The European resource group is set with policies in place that only a location policy in place that only allows the regions in Europe. So we can do all of that with policies and with initiatives. And again, initiatives, the difference between when we're talking about policy, an initiative is actually a group of policies. So when we think about the two, and we can walk through that real quick just to kind of show everybody what that is here. So let's go to policy real quick and show those definitions. And what you see here is you actually see, the initiatives are what's at the top, and you can see what those are generally a number of policies, and then we have our policies are actually specific things, and we can see what category they're in. They're in different categories depending on what where they fall, and we can can identify, or we can search on different categories or capabilities, what type they are, whether they're built-in or custom, whether they're initiative or policy, and we can search based on a number of different things. So and we can put these in place, and as we put them in place, we modify what we customize them as we needed. Like Cosmos DB allowed locations, we can determine, okay, what regions it's going to be allowed in. So you can do a lot of different things with the policies and with the initiatives of the policies. Azure Blueprints is the next thing to talk about here, and what Azure Blueprints does is it's ultimately takes those resource manager templates, those ARM templates, and allows you to build in role assignments, policy assignments, and your resource groups, and just create. If you think about a blueprint of a house, it's creating everything that makes up that house: the walls, the doors, the heating and cooling, the electrical, the appliances. All of that goes into that blueprint, and we can then take that blueprint and hand that to a general contractor. They'll get the people that are needed and the resources needed to install those. That's exactly what Azure Blueprints does from an Azure deployment standpoint. Cloud Adoption Framework is a piece of Azure and what Microsoft has built in terms of a strategy and an approach to take you on your journey to the cloud. So as we kind of go through, and we've talked about the tools and how we're utilizing the tools and how we're going into Azure and what services and subscriptions we're utilizing within the cloud, how are we getting there? And that's what Cloud Adoption Framework helps us with. It helps us to strategize and plan, and then get an idea of what we have that's ready for the cloud, to take it to the cloud. And that might be from a standpoint of what we're taking to lift and shift, or whether we're modernizing our applications and workloads to get them into the cloud, to start innovating and becoming more cloud native and utilizing more platform services, and then ultimately then how we continuously then govern and manage those resources. So once we get into the cloud, how are we then governing and managing? And we've talked about some of those tools already in terms of policies and blueprints and things to do that. Azure Monitor are all those govern and manage aspects. So let's talk a little bit now about privacy, compliance, and data protection. And this will get us, circle us back around to the security levels for education, where we talk about what is security, privacy, and compliance. And security, privacy, and compliance, one of the things, and this is really from an Azure perspective, we want to be secure by design, and Microsoft has built those baselines to provide a base level of security within their infrastructure. All of the everything that's Azure Monitor and the automation and the artificial intelligence and machine learning pieces that Microsoft has, all of the information they gather globally about cyber threats, all go into your environment, and all are work within your within your tenant to provide you with those guidance. And that's really where Azure Security Center and help out, provides that information. Azure Advisor, all of those takes those best practices of what's secure by design and provides those recommendations to you. In addition, you can actually turn on a security baseline around your Azure Active Directory to just set a baseline as you start within your organization. Privacy, Microsoft's committed to maintaining the privacy of the organization, through the contractual agreements. They're very transparent in terms of information, and then compliance. The local laws and regulations, they provide a lot of compliance and comprehensive coverage around compliances. And when we think about compliances and the requirements, one of the things that Microsoft does do is they are very strongly involved in maintaining a level of compliance for their infrastructure. And what that does and what that includes is around these regulatory compliances and how they're protected within the organization. And they provide then guidance that you can utilize within Security Center and the Service Trust Center and Compliance Manager. All of these different services within Azure and Microsoft 365 can help you to maintain your own security levels, and that includes education. One of the key secure regulatory compliance levels for like education is FERPA, to protect the personal information of educational organizations, and Microsoft has baseline audited requirements that they've met and controls they have in place for FERPA, for their physical infrastructure. And then they can provide you as an organization with the additional recommendations and controls that you should put in place to maintain that level of compliance for FERPA as well. So, and some other, others that are noted here that are popular in the United States, like HIPAA or NIST, as well as like different EU models, GDPR, all of those fall in there as well. Microsoft does have a privacy statement. That privacy statement just is really their level of transparency and what it explains in terms of what they do with the data that is processed. They also that they're not going to take your information and sell it for marketing purposes, things like that. And then the online services terms and data protection addendum. There is every organization that goes into the Azure environment or Microsoft 365, there's an online service agreement that really lays out what the service level agreements are between Microsoft and the customer, and then that data protection addendum that they are going what they're going to do in terms of protecting that data, both customer and personal data, as is the case, as in what they come across and what they handle as part of the online services that they're providing you. And all of this information is very easily found by going to the Services Trust Center. If you just keyword Microsoft Trust Center, you should very easily find that in a search engine. It provides all those privacy all the privacy information. It provides all the information in terms of their compliance attestations. You can search on different compliances, or you can go into the compliance center and gather that information. But all of that information, they're very transparent within the Trust Center. And again, that compliance documentation is also noted and mentioned based on global U.S. industry or region as well. So if we were to go right now and go into the Trust Center, which we'll do here quick. And as this comes up here to everybody, you can see the Trust Center has across the top, security, has a whole bunch of security solutions, security overview. Here's where we can get to the privacy, data privacy, GDPR, other resources in here, compliance, and the compliance offerings are up here as well. And we can go then into the compliance overview here. And here's where we can see like audit reports. We can see and scroll down to additional resources. We can go to the different compliance offerings, and here we can actually see those industry and global and U.S. government capabilities in here. And if we go right into the first, one of the second box here of industry, we can see here from a level we can see FERPA for the Family Educational Rights and Privacy Act, and we can click on that, and it takes us right to the requirements and what the overview is of this and what the scope of services are with Microsoft in terms of what they require, what audits and what certifications are required for FERPA as well, and it also it'll say how Microsoft complies to it within this documentation as well. And as we come back into the slide presentation, I said we were going to revisit certain things around like China and Germany and Russia here later on. And that when we talk about that, we're talking about really like the sovereignty and sovereign regions. Microsoft has some U.S. government sovereign regions, which are actually, Azure government is a separate, complete instance of Azure. That is separate from the consumer cloud essentially within Azure that is compliant with the heavy federal type standards like FedRAMP and DoD level standards that you can get a certain level of those for running government workloads within the Azure Commercial Cloud. But a lot, when you're working with putting resources in the cloud for federal government, they require these levels of standards and require it to be isolated into the Azure Government Cloud. And that's really what when we're talking about sovereign regions, we're talking about separated Azure instances or data centers that really don't intertwine with the general commercial cloud. And the next one really is the Azure China. Azure China is actually operated by the Chinese government through 21 ViaNet, and it is again a physical separated instance of Azure services. So that's not actually even run by Microsoft. So a little different there in terms of how Azure China works, and how how you would do business with China would be a little bit different. So keep that in mind. And just to kind of put it in context, the German region and the Russian region are very similar to the China region, except Microsoft does run those. I believe they do run those under the guidance of the German and Russian government, where the Azure China is actually specifically run by China and 21 ViaNet. It's more like similar to having like an Azure stack within a private data center to a certain degree. So true or false, let's get into the knowledge check here on objective 5 before we get into the final objective of the day and wrap things up. True or false, Azure policy is used to control per user permissions in Azure and control the types of resources that users can deploy. And that is actually false. That description is more around the user controls is more around role-based access control. Policy focuses on the actions on the resource rather than the user's actions on and what users can perform on that resource. So keep that in mind. There always seems to be this tie-in between policy and role-based access control within the courses that I teach within Azure, when they're really pretty mutually exclusive. But understand that the roles are what the users can perform, the policies are what can be, is really the focus is on the actions on resources. True or false? With infrastructure as a service, you're responsible for the maintenance and patching of physical operating system hosts in Azure. So this kind of takes us back, we're governing our resources, and we're going back to kind of that shared responsibility model thinking here in this question, and kind of reviewing back to even part one. The key here is physical operating system hosts. That host name really completely makes this false right away. So Microsoft maintains physical infrastructure. So anytime you see physical hosts, understand that is Microsoft's responsibility. If it was saying the virtual machine operating system, then we were okay, and that would have been a true statement. But since it said physical hosts, the host operating system, that's not it at all. What would you use? Next question. Give a second to refresh here on your screen. What would you use if you want to avoid a resource in Azure from being modified or deleted? This is a good one here. And this one would be a resource lock. We use that do not delete, or we either read only resource lock to avoid that modification or the deletion. The modification would be the read only. The deletion is, well, the modification or delete would be read only. If we just needed to make sure that deletion didn't take place, it would be the do not delete. All right, let's get into pricing and lifecycle. And like I said, we are on the home stretch. This objective doesn't take that long of amount of time, so we should be good to go here. So we're going to talk about what affects costs, how we're going to manage cost, how to reduce and control cost management. We'll talk about service level agreements and what impacts service level agreements, and then product life cycle. So not too long to go through these particular resources and touch on the requirements here. So key things around what affects our costs, and there's really 6 things that affect our costs, and we'll talk about 3 of them on this slide. Key things is what the resource is, what the service is, what the location is. So when we talk about the resource type, generally our costs are around, and we're going to be charged for what we're using in compute, networking, and storage is generally where costs come from. So the level of what that resource type is and amount of compute and resources it's utilizing is going to be, that's a metered service, right? Excuse me. The services, how it's being billed, but whether you're utilizing Web Direct with your credit card, whether you're using an enterprise agreement, or whether you're utilizing a cloud solution provider. Those all are different ways in which our service, which might affect our cost or how we're billed, right? Our location, where locations are being utilized. There are different costs in different, costs may vary in different regions is something to understand. They become a little bit more consistent. There used to be like maybe a 10 to 15% difference from U.S. services to like European services a few years ago. I think they're pretty much on par now. When you think about like services, though, if you need services like you're utilizing resources in Brazil, because Brazil is not is still a fairly new and not fully utilized type region, there's a little bit higher cost. You're not getting the same economies of scale that you are in Europe and the United States, because there's thousands of customers running in those regions. So there's going to be there's a cost savings that you get there. The next things to think about are bandwidth. What bandwidth, the amount of bandwidth you're utilizing. Microsoft generally, for putting things into Azure, generally does not cost you anything, but pulling things out of Azure or accessing information within Azure and pulling that data out, that bandwidth is chargeable in most cases. Reserved instances is a way to save money. If you have a resource that runs at a fairly static level, that you're not going to, that it's going to run pretty similar, 12 months out of the year consistently, without many changes. You could put that on a reserved instance and save quite a bit of money. Like I said, depending on whether you're doing it in terms of a 1 year or 3 year, it could cost you 72% less, just because Microsoft then, the dynamic nature, obviously people that are utilizing resources month to month, obviously their Microsoft's revenue is fluctuating based on customers that are creating resources and removing resources on a monthly basis. If they can forecast that a customer is going to use this amount of resource and they're going to get this amount of billing for a 3-year period, they'll give you that benefit just because they can now forecast a little bit better as well. So a big benefit there. The hybrid use benefit for customers with software assurance and enterprise agreements, they can save on the operating system costs and the operating system licensing. Microsoft will allow you to declare that, hey, I've already got a license for Windows Server 2016 or for SQL Server 2016, and you can bring your own licensing and save some money as well. Generally what it is 30 to 40%, for that license. If you're trying to determine what it's going to cost for you to go into Azure and to stand up resources within Azure, Azure has a pricing calculator, and that pricing calculator is that tool then to estimate those costs. You can estimate those costs and adjust and look at different regions, to look at different billing options, look at those reserved instances, look at the different offers, look at what are free services. It's got every one of Microsoft's services in there, and you can play around with that and actually get an estimate that you can export out and really present to your organization that this is what we estimate taking this workload into Azure is going to cost, versus here's the cost of us purchasing a new server that's going to handle us at 100% capacity. And look at this. Okay, here's our cost 9 months out of the year for this web service. Here it is, for the 3 months around Christmas, versus buying this big beefy server that's going to just handle our 75% spike at Christmas time and then run at 25% the rest of the year. TCO calculator takes that a step further, where you can plug in certain parameters around your virtual machines, your storage, your databases, the amount of data that you're going to use, and it'll actually do a quick calculation of what you might save versus running this all in your own data center. And it takes into account certain things in terms of overhead savings, and if you're utilizing platform services and things like that over 1, 3, and 5 year periods. I've found that the total cost of ownership calculator is a little buggy sometimes. It's not always the best tool. I do use the pricing calculator quite a bit when I'm trying to find cost estimates. The best way to know whether you're going to save money or not is to understand to what level you're going to be able to decrease your capital expenditures if you have hardware that's depreciating versus any any investments that you have versus what you might have in terms of a budget of ongoing operational costs and overhead that you might be able to decrease and focus on more application development within your IT organization if you were to move things to the cloud rather than needing to manage and maintain a data center. And then the other piece to consider here is also the cost management portal within the Azure portal and the Azure environment. Here you can view your costs and get real-time understanding of what's going on with your environment. It actually goes down to, if you're looking at a monthly snapshot, it goes down to 0 every month and obviously is going to increase as the month progresses. But you can get an idea. You can look at the previous month and it'll tell you, what you this one actually shows that you budgeted $4,500 per month. And here you are, at the 19th, you've only got 11 days left in the month and you're only at 2746. So you should be pretty good. And you can get an idea there of what's going on in your environment. You can get alerts in terms of whether you're getting to the point of exceeding your limit, and set budgets and set spends, and also get recommendations in here as well. It's tied into that Azure Advisor that I showed earlier and shows you, hey, here's, it'll tell you, hey, you might want to use for this virtual machine reserved instances. And here's just some this slide here, and we'll let this get caught up because it gives you a little bit more detail around how to minimize and manage your costs. Is to do your cost analysis. Use the tools in terms of Azure pricing to understand what your costs are going to be before you go into the Azure environment. Continuously utilize use those recommendations that Azure Advisor provides you. Creating those spending limits is important, and I've used that myself in terms of trial licenses or credits that I only got $100 credit per month to utilize. I'll put spending limits to let me know when I've hit like $25, and when I've done a class and I've hit too much, in my spending limit, it'd send me an email, and I'll know I forgot to turn something off. The Azure reservations, I said, are very helpful if you've got resources that are very easily predictable and how much resources they're going to use, and those hybrid use benefits are also helpful as well. Choosing those lower cost locations, using that pricing tool, and look at those locations. Maybe East US is less expensive than Central US or North Central US, and where our users are going to connect doesn't really make a whole lot of difference which one is utilized. Pick the one that's got the lower cost to it. Keep up to date. Obviously, there's lots of offers that take place around, and subscriptions change and costs change within those subscriptions. Understand that. Set your tags for setting the ownership environment. Understand how that's going to be utilized within the Azure environment. Apply those tags accordingly to set the different departments, in cost centers if that is how you're going to utilize the Azure environment as well. So the last piece I think that we're going to hit on here is then the Azure service level agreements, how service level agreements work and act, and then the life cycles of services. So key things to know is how services roll out within Azure and understand how those work. And when we're talking about service level agreements, this goes all the way back to when we were even talking about our virtual machines and talking about what the service level is based on if it's one virtual machine or it's or if it's two or more virtual machines in an availability set or an availability zone. Those are ultimately the service level agreements. That's the level of commitment that Microsoft has that service is going to be available when needed. The commitment of uptime. It's based on each of the products and services, and you can very easily find those by just typing in Azure service level agreements, and it'll take you there, and you can find each of the services and go through there. Keep in mind that anything that's free or preview services, they don't offer SLAs. These are only ones that are actually tied to any monetary means that you're paying for, because as the next slide will show, that service level agreements will provide you, having service level agreements, you could get credits on those. And here's your different service level agreements. So I was somewhat close here. So downtime per month within service level agreements is generally based on a percentage level. And as I was saying, a single virtual machine is at 99.9%. And I said that was about an hour per month. It's actually more like 45 minutes. I was a little bit off there in my estimate. And it goes down to 4 minutes per month if you have two or more virtual machines tied to an availability set for that virtual machine. So duplicated virtual machines actually takes that down by almost 40 minutes per month of potential downtime. And so that's, and if you're at 5 nines, which there's very few services that give 5 nines versus within Azure. I think Cosmos DB might do that. And that's 26 seconds of downtime per month, less than 5 minutes per year. So that's the highest level of, that's almost perfect. And if you in a month's time find that your single virtual machine has been down more than 43 minutes and 49 seconds, and you can provide proof to Microsoft, you can then do a credit request to have that refunded or credited to your next month's bill for the amount of time that it was down for that 44 minutes of time, or anything over that 44 minutes. If it was down for an hour, get credited for that, for that delta. So that's really what it comes down to, and what the service level agreement is, and how it pertains to the products and services. Certain things that affect those service level agreements is and what you can do to increase those is just like I said with a virtual machine. If you use to raise a virtual machine's service level agreement, you can put that virtual machine in an availability zone. If you or utilize different redundant systems such as geo-replication and things like that within like Cosmos DB or platform services, also increase those SLAs. And there's a lot of things that can raise or lower those SLAs. And it's ultimately, as you build more resiliency and high availability within your infrastructure, understand that as you do that, when you build more high availability, you're increasing your availability of services, and ultimately could be increasing also the SLA within the Azure environment. So when we think about our resources and new services, products and services coming into the Azure environment, the things to think about is how those services are utilized and how those come online and what the life cycle is. And that's really where we talk about the preview program. Microsoft has taken one of the previews off of this list. There used to be a private preview, which is only for select partners and MVPs that have made a request to review that. Since very limited people and customers have access to that private preview, they don't really recognize that anymore in this presentation. So keep in mind, we're talking about public preview and general availability. You have access to that. You have access to those resources. The key thing around, you can evaluate those resources when they're in public preview. There's still an evaluation. There's no service level agreement. There's no ability to get credit for downtime. There's really no support to it. You can generally, if you want support, you probably need to just go through public forums and see if anybody else has had any issues, because Microsoft's not going to provide any level of support. General availability is that it's supported by for all customers. It's got service level agreements built into it. It's got a support capabilities. All that's in there. And you can monitor those service features very easily and get updates on those services very easily, utilizing RSS feeds within to get Azure updates. And not a whole lot to really cover here, but you can search updates by keywords and go into Azure updates and get alerted if that's something that's important to you as well. So let's go into the last quick knowledge check here for the day. So true or false, and let this all catch up here. Bit of lag here today. An Azure subscription may only have one account owner. And that is actually true. You can only have one account owner. Each account owner can have multiple subscriptions, but a subscription has one account owner. Keep that in mind. Just good information to know there. Some things on support levels here, which is good to know, because there wasn't really a slide on this, but something to understand what level you might need in terms of your organization. Relies on Azure services for critical applications. You need 24/7 support. Which of the following support plans is the most economical option but still get 24/7 support? And this is the standard plan. Actually, it'll give a level of 24/7 support for critical operations. The Professional and Premier also provide 24/7 support with a little bit quicker response time, but it's the more expensive. So you do get 24. If it's a critical application, you do get 24/7 with the standard tier. You can't get it with developer tier. Oh, this is a repeat, I think, of the last one. Yep. Sorry, repeated there. Next question, at which stage of the Azure service lifecycle should you consider an Azure service in production? Development, public preview, private preview, or general availability? And we just talked about this here a few minutes ago. It's general availability. This is in production. It's got support. It's got an SLA. That's what would be considered production. Private preview does not have any of that. Neither does the public preview. All right, we've gone through everything. So some final thoughts and things, and something I'm going to do here. If you have a QR reader, I have a quick survey. If you could do that for me as a trainer, I would appreciate it. Keep in mind when you're going through the survey, it doesn't take into account the difference between a fundamentals course and a regular associate level course. So on some certain questions don't really pertain, so be easy on me on those questions, please. I'll hit on some questions here that are in the chat here while you're doing that and while we finish up. And a couple of these kind of go really good with what I wanted to cover here. So hopefully we did the security level for educational purposes, and understanding that you understand the compliance levels and the requirements for the education is really where you then set those security levels. And really, if you follow base level, even the security baselines that Microsoft has in place for for like CIS, the CIS baseline, you're going to hit most of the requirements for a lot of regulatory, privacy type levels, in terms of GDPR and FERPA and all of that is very helpful there. So I appreciate that there. Some things around the actual exam to talk about. There's a few questions in the chat that are really that really kind of give me some starting points on that. Where will there be any hands-on implementation questions on the exam? Fundamentals exams, and to kind of talk overall around the fundamentals exams in general. The fundamentals exams are very straightforward and are usually, you might get some situational type questions, but they're generally typically pretty straightforward multiple choice type questions. You might have some hands-on type implementation type questions if you get into an associate or an expert level, but not really on the fundamentals level. So keep that's a really good question there, and really good around what I wanted to talk about around the exams anyway. Understand that you're taking a fundamentals exam. It's pretty understandable in terms of what certain things around definitions and why you utilize certain services in certain cases are really the fundamental topics that you're going to get asked about. Do you need a passing score in each area, or is it the overall score? So exams in Microsoft, and the fundamentals exams in particular, are generally 40 to 60 questions. So you have 40 to 60 questions. We have what those questions are based on those weighted tiers that I showed this morning when we first started talking. Each of the 6 sections being anywhere from 10 to 15 to 20 to 25% of those areas. You do get scored essentially on each area, but you don't need to pass each area. So when you get your score report, it's going to show each objective area and going to show how you did in each area. But your overall score is based on a scaled 1,000 point scale. So those 40 to 60 questions make up 1,000 points, and you need to get 700 points. And it doesn't matter. I mean, you could completely bomb a particular objective area and still pass, as long as you've passed like really the higher weighted areas. Like I said, the Azure Fundamentals is pretty evenly weighted, so you have to be probably close to that 70% in every one of them to pass that exam. If you're below in one, you probably need to be high in the other to get that, to make sure that weighted score, gets over that 700. If you don't, in some of the other ones, some of the other exams, for example, you might have 4 objective areas. One's 10 to 15%. The others are 20 to 30% of the exam. That those 3 objective areas that are 20 to 30% are the ones you really have to focus on. Unfortunately, with the Azure Fundamentals, you pretty much have to focus on all 6 of them, because all 6 of them are going to have a very strong basis to you passing the exam. Those are kind of the key things to note and to think about when going through and understanding the exam. So, we're about 15 minutes to the hour. We can I can stick online for till the top of the hour for everybody. And if there's any additional questions, feel free to post it in the chat. If there aren't in the next 5 minutes or so, we'll probably just close out a few minutes early. But I want to thank everybody for their time today. Again, I think the presentation was just posted for everybody to access. So feel free to download that. Again, like I said, all of the knowledge check questions that I went through talking about, as well as a link to forms quizzes for each of the modules or each of the objective areas, were were in there as well, so you can use those as practice questions as well. So I will stick around here. I think we have the pending questions. Somebody is Adriana. Somebody is asking where is the link to download the slides. Can you come off mute and let them know where to find that, please?
Yeah. The slide should be under the file panel. It should look like a paperclip in the bottom left-hand corner of your screen. And then it should say Microsoft ExamCram AZ 900. When you click on that, it should download for you.
Thank you very much. And again, just some final thoughts. Feel free to reach out again on social media to me. I want to hear, when you pass the exam. Nice. I always like to hear that. It was not this particular path, but I taught a Microsoft 365 fundamentals class on Saturday for my company, and woke up this morning that somebody that took the class obviously was taking it in the middle of the night, because I think they were in India, and they got up this morning, took the exam, and passed it. So I had them telling me already that just from the class Saturday they already passed the fundamentals exam. So so I like to hear success from people that have been in one of my trainings. It's nice to kind of hear that you're succeeding. Part of being a teacher is the success of the students. As many of you probably know, if you're instructors on this session, know that you're graded and thought of by the success of others, and I feel the same way as a technology trainer. And I appreciate everybody taking the time today. And another question come up around practice exam resources. Microsoft does have an official practice exam that's available, and I believe that the practice exam was part of that Get Certified offer as well. If you are lucky enough to get to claim and to be drawn for that program, and to claim that, I think you get the practice exam and that retake voucher for taking the exam. But that's the official practice exam for Microsoft it's through Pearson. It's Measure Up. You can find that very easily through a search, and that's really the endorsed practice exams from Microsoft. All right, Adriana, I think we could probably stop the recording now. I think the specific questions have ended and everything. So I want to thank everybody again and have a great day.
All right. Thank you, everybody, for joining us today. As a reminder, you can access this event recording at the same location you joined today's event. And the files and the slides, are available via the Files button at the bottom left-hand corner of your screen. I'd like to extend a thank you to our presenters, and this concludes today's event. You may now disconnect after completing a short survey that will appear in your browser shortly after the stream ends. Sorry.